Okay, so here we are, and these are the application nodes. So these are actually running applications. So let's switch this and say, you know what? This is just a node. So this is just a node. This is just a node. That's all these are. These are nodes. And let's say that we obviously have need to have multiples of these, but let's just say we're going to have one primary, which is a master. Okay. Now, obviously in production, by the way, you'd probably want to run more than one just to make sure you have a quorum, particularly if there's any kind of like disjunction. Usually you run odd numbers like 3, 5, 7, 9, etc. There is only one master active at any given time. And they're not using like any kind of like complicated like SIP protocol or whatever, like a gossip protocol or some type. But it is good practice to have run an odd number of masters typically. All right, so let's say that we've got a master, we've got a couple of application nodes, because master being the other node type, by the way. So, by the way, what's on the master that helps control the nodes? What kind of services are running on the master that are useful for helping with Kubernetes? And this is relevant, I think, particularly for things like attack service and whatnot. But what's running on here? I mean, one of the services that are running on the master node. So we've got etcd on here, right? etcd is handling what? Oh, you got the API server. That's another good one, right? All right. What's etcd handling, by the way? What is etcd? It's a database key value store, right? But what is it storing inside etcd? The database. Yes, that's true. What is it storing? Like, what is inside of the etcd database for Kubernetes? What's there? Credentialing. Yeah, there's probably some credentialing there, right? Well, because everything in Kubernetes is API driven, and Kubernetes runs off this concept, right, of what? Like, what is a deployment? What is stateful sets? What is even a node? Like, what is a pod? These are all for all objects, right? So Greg, that's good, right? This is basically all of the state and configuration details for objects, right? Now, this is also last known state because some of these objects are distant, right? So, but they get managed and reported like back to and updated inside the database. By the way, is there anything else on the master servers themselves? What else is there besides the etcd database? Obviously the API server, which handles the API calls. What else is here? Well, there's definitely a control. There's several controllers of some type, by the way, right? Including ones that could govern into authentication, right? There's controllers, there's cloud controllers. There can even be like storage controllers here, right? There can be admission controllers, right? Mission controllers are pretty popular, right? Especially when in conjunction with PSPs. So that there could be a number of controllers here of varying types. Cloud controllers, by the way, in particular, they're the ones that probably come and go the most. It just depends on what cloud provider you're running on, right? So there's a number of services here that are running on your master. By the way, can the etcd database be externalized? Does it have to sit on the master? So we know the answer to that. Yeah, it can be externalized. That's exactly right. So you could actually run a separate box and put your etcd system outside of it if you wanted to. That can be good practice, by the way. I wouldn't say it's best practice. It can be good practice because if you take your etcd database off, you can then basically block all access to the etcd database except by the particular systems in question on the particular port in question, right? Otherwise, it's a little loose and fast with authentication mechanisms here. So that can be a great way to control it. You can also scale it, by the way, independently of the masters as well, which can be also nice. Back it up, manage it as a separate data store, manage it as a service. Okay. Let's pull the rest of this off to the side. All right, so that's what's running on the nodes for the most part. Sorry, that's what's running on the masters for the most part. What's running on the nodes? There's at least 2 services that are usually running on the nodes at any given time. There can be more depending on what you've run on them. But what's the one thing that the masters uses to talk to the nodes? It's not controllers, by the way. Ignore that. What is running here? Yeah, the kubelet, right? So the kubelet's running here, right? That's important to know because that's like the core software that basically interfaces with the controller, reports back status, does all the metricing. What else is running here? Here's an interesting thought. How does all that crazy networking that we were talking about before, how does that actually happen? Yeah, kuproxy. Good. Can there be other pieces of software on there? Sure. These are the 2 core for Kubernetes. If you add additional features or extend custom resource definitions or put operators on there, there could be additional pieces of software, but these are the primary 2 interfaces from the nodes back to the master. Okay. All right. Now, if we wanted to create a virtual slice of our clusters, which also has security implications as well, as far as like being able to partition users and objects and other pieces from each other. We wanted to slice these things up into virtual slices. We talked about this yesterday. Right, we would namespace them, right? Now, these are just virtual slices, and I'm drawing it over the nodes, but basically these slices exist over everything, right? So although obviously this mainly applies to pods and other kind of user-based objects for the most part, obviously it exists over the entire cluster, but it mainly applies to the nodes that this would can multiple namespaces exist on a single node at a time? Actually, just to say this is cluster wide. So you can have all the namespaces exist on all the nodes. I don't even know that there's a way without doing some really weird jury rigging to exclude a node from a namespace. It doesn't mean that it has to get scheduled for a namespace, but when you create a namespace, that's cluster wide, right? To my knowledge. And so like, I don't know that you can actually like, I think people have asked me this before. Can we exclude a namespace from being applicable node? It's like, no, but you don't have to schedule anything on that node from that particular namespace, but it's still, this is the node still knows the namespace exists. It's just not getting pods from it, right? So basically all namespaces exist on all nodes in the cluster. I mean, can pods from a different namespace run on a node at the same time? Oh yeah, definitely. Yeah, that's a core concept. Yeah, Greg. So when you slice up like saw me, I had Jenkins and Ubuntu and all that stuff. They're all running on Minikube, and they were all running in different namespaces on the same node. So the namespaces have partitioning information or security information from a cluster-wide perspective, but unless you actually set some kind of affinity or anti-affinity in the pod, which is something we're actually going to talk about, I believe today, it might be tomorrow, the pod's going to go on any node that has access into the cluster. It's not going to have any restrictions on it just because it's in a namespace. So yeah. All right, so namespaces are a way for us to create these virtual partitions from a security perspective, but they do apply to all nodes in the cluster, so anything can run anywhere, right? You have to use some kind of other selector or label selector or affinity or taints and tolerations, which taints and tolerations we'll also talk about, I believe, today as well. But these allow us to basically create some segmentation. If you ever used OpenShift, by the way, OpenShift takes the concept of namespaces and enhances it greatly. I think they call them projects, right? But they basically have enhanced the namespace security core to an even tighter. That is, by the way, one great benefit I will say of paying Red Hat, IBM to use OpenShift. Even though it costs money, Red Hat has actually done a tremendous amount of security enhancements to OpenShift that do not exist in the general population of plain Kubernetes clustering. So something else to think about if you ever need that assurance. Plus, sometimes it's good to have a vendor to talk to. All right. So let's say we've got our namespace, which I'm actually just going to put down here for a second. Actually, maybe I'll just make it smaller. We'll make it a different color. I'll just leave you right there. Okay. That's not contrasting enough. Let's do a different color. There we go. All right. So we can have multiple namespaces. That's slicing across the system. All right. So now, what is the basic wrapper around a container inside of Kubernetes? What's the basic unit of like kind of management, if you will? Like these containers down here, like let's say that we lost our minds for a second and we decided to run these together, and we wanted to have shared networking, wanted to have shared memory space, we wanted to have access to the same storage, right? We would put them in pods, right? So we put them in pods. Well, we have you go back just a little bit more. A little bit more. All right. I don't want to send you to the back because then that's going to be weird, but whatever. Guess I could use the control down arrow. There we go. All right. So let's say we sent this. This guy's now in a pod. So this is a pod definition right here. And so in our pod, we're sharing the same namespace. We're sharing IP information, right? Things are able to easily talk to each other. And let's say that we had a sudden outbreak of sanity and we decided that we were not going to run our database in our same pod because we didn't want to scale the database and the application at the same time, particularly because it's MySQL, right? And so we decided that in here, we were actually going to put an operational pod, operational container, because we wanted to make sure that this actually spoke to our app. And we also decided that we were going to put a security container in here because we wanted to make sure that there were some concerns that we had that were not like left behind. So now we've got a security container in here and we've got an ops container in here as well. And this would be a good setup, by the way, for your pod to have multiple containers in there. Notice I only have one app that's in the bright yellow, and I'm not sticking my database right inside this pod as well, because I don't want it to have to do some kind of weird scaling, because this is a MySQL database. It's not a NoSQL database. And I don't want to have a 1-to-1 ratio between my application and my database. So I'm not going to stick it inside this pod, because this whole thing is then going to get copied and scaled, right? So now if I do this, this is now a stateless app that I've got running inside my system. Now, if the pod is the basic unit of execution, basic unit of deployment, right, inside of Kubernetes, is this a stateful or a stateless pod? Stateful or stateless? Oh, and by the way, we could put this namespace over it, right? We could say this is running in a namespace, right? By default, it is probably running in a default namespace. But is this stateless or stateful? Yeah, it's stateless because there's no volume associated with it, right? So there's no data volume, there's no data storage attached to this system, right? So let's say that we're humming along, everything's looking good, and we've decided that we now need to add some state to our system. But hold on, wait, before we do that, wait, let's think about this for a second. So we know that these containers inside this pod can all talk to each other. We know this container can talk to each other. We know this can talk to each other. can these pods get together? Like, can they talk to each other across the cluster? So depending on the networking driver that you use, there's typically an overlay network that allows these guys to kind of like be aware and talk to each other. Now, pods are typically isolated, so there is kind of like a network inside the pod, and then there's an overlay network outside the pod itself, right? That in a sense kind of represents the cluster's IP space. So much like, we're gonna kind of borrow this for a second, much like this is like a namespace. Namespaces, by the way, have nothing to do with the networking. I'm just borrowing this visual for a second. These guys, basically, the cluster does have a cluster-wide kind of network that it can use to kind of interact and talk with each other. That's different from the actual host's IP address. If there was like a host IP address attached to each of these nodes, right? There's a network for the host. There's kind of a, in a sense, a network for the cluster. And then the pods each have their own individual network space inside the pod. But communication between the pods is external. It's not like this guy in version 2 can talk directly to this guy over here. He's got to go outside the pod and then get over here to this section, right? So there's isolated networks. There's the pod network, there's the clusters network, and then there's the actual physical host network as well, right? All right.
I
So
have a quick question.
ask away, Greg.
So let me guess ahead real quick. So by default, any pod can talk to any other pod in the cluster unless you set a policy restricting that, right?
Yes, you can actually get to other pods in the cluster unless you actually set a restriction for it. It's because,
Okay.
yeah, it can leave and go out through the cluster network and communicate with each other.
Yeah, I was just curious about the scope of the intercommunication, but basically it's wide open unless you explicitly restrict it, right?
Yes, but like to say this, like most implementations, like for example, if you go to a managed service provider, you grab Rancher or you grab OpenShift, they will restrict it, right? They will start to like control it, but vanilla wise, it is wide open until you apply some kind of policy, right?
Okay, thanks.
So
I had a question as well, sorry.
Go ahead, William.
So that cluster overlay network, would that go through the Q proxy, or is that only communication to master?
Actually, that is actually what the Q proxy is for the most part.
Okay.
It's not only to externalize services, but also to manage the basically the overlay network as well.
Okay.
Yeah. So that's a good point, because that's where we're headed next, William, is that let's say, for example, that we need to take these pods and externalize that as either a DNS name or an IP address, right? What do we call that, by the way, when we needed to externalize something out? We needed to take a pod set and externalize it out. There was a particular word that we called that. Because we talked about exposing, right? That's the action. But what is that object called inside of Kubernetes? When you want to expose something through a single persistent endpoint, regardless of how the pods come up and down. A service, right? It's a service. Nope, not doing that. So let's say that we come back and we define an object and we say, look, I've got a service that I want to run. I'm gonna put this right on the fringe down here, right? I got a service that I want to run. And what I want is I want to make sure that no matter what happens with these pods, that I've got a single DNS and or IP space that I can go to, right? So what ends up happening is that this service actually links in to these pods. If these pods are replaced, by the way, because you may remember this from yesterday, but when we were looking at Nginx, for example, it was doing Nginx and then was dash and it was like a random name, right? And so every single Nginx pod in that set ended up with an individual randomized name, but it all started with Nginx, right? So, which we'll look at in a second. By the way, these pods could come and go. They're stateless. Kubernetes could move them around. It could lose a host. It could run out of capacity and resources. So it might decide to kill these pods at any point in time and then just move them around. How do you then maintain persistence of connectivity? Well, this is how you do it, is because you've got the service here, right? And this service, by the way, tracks when new instances of, say, our Java app starts up and basically says, oh, I've got new instances, so now I can route to this guy. And by the way, there are health and readiness probes, right? There's aliveness and readiness probes that you can use to check to see whether something is alive versus whether something is actually ready to take traffic, right? And these probes, once they're passed, they get like inducted into the service, right? And so anytime a new pod is started, if one is added, one is dropped, it gets added to the, in a sense, the registry for the service discovery. And then if you hit that service by IP address or by DNS name, which again will result in the IP address, it will route to the service on the back end. Does the service provide load balancing by default? Yeah, in a very loose and rough sense, right? You're better off using an external load balancer. So, because if you use a cluster IP, it's not necessarily going to track by like least connection or some kind of other weighted algorithm. It's pretty much going to do round robin. Obviously, if a service becomes unresponsive, it's going to take it out. Like, so it does act like a load balancer in that way, but it predominantly does round robin. You do have some control over that. But if, again, I think I've said this before, if you're going to run any load of significance, yeah, it's baby's first load balancer. That's exactly right. If you're going to run a load to any significance, please actually just add an official load balancer. Nginx can act as a load balancer. F5, you can get all kinds of virtual machines, virtual containers for load balancers. If you're on a cloud provider, you just use the cloud provider's load balancer. So get AWS, get an ALB or an NLB if it's Azure, so on and so forth. Because remember, this service, by the way, could actually mount to a host IP address, can mount to a cluster IP address, or it can mount to a load balancer IP address. That's called node port, cluster IP, and load balancer are the three service backend types you get defined, right? Okay, so customers coming in and they are talking to us traffic-wise, they're coming into this service, and then we're coming in and we're routing basically to the appropriate pod in question. Now, remember, it's probably coming into our yellow Java app, our fabulous Java app, but just as a throwback, you could actually have the service directed to the ops networking filter or the ops, or maybe even a security filter, and it's routing traffic over to your Java app. In other words, don't get fooled. Just if you have a pod and there's multiple containers in there, you could actually route to another container to have it route to your application, which, by the way, is how service mesh works, because that's called sidecarring, right? In the load balancer case, if you're using provider's load balancer, that still runs as a pod in your cluster, or is external? It's external. So, Mike, this is where, by the way, the cloud controllers come in. The cloud controller up here on the master, if there's a cloud controller for AWS or a cloud controller for Azure, depending on what platform you're running, it actually links the load balancer in as an external object that it's managing in with the service definition down here. So this service, actually, if it's on a cloud, is actually sitting external. It's actually an external load balancer that's sitting on AWS. It's not sitting in your Kubernetes cluster. So the load balancer could be a pod on your nodes here. If you're running Nginx or F5 or something else that you want to use as a load balancer inside your cluster, or it can be an external object that Kubernetes is managing for you using the cloud controller up here off of the master set. And to date, I think Kubernetes has a cloud controller for every major cloud provider that at least the ones I've heard of. Yeah. Cool. Okay, so all of that was just to talk about services. There are, by the way, these things called ingress controllers, which we will touch on briefly today. But services basically allow you to have a single IP address or DNS entry to get to many pods, especially as the pods go up and down. Now, when we deploy stateless apps, when we were looking at this yesterday, oh, wow, that is way too small. Let me just check on this really quick. Oh yeah, we're good. Okay, when we looked at this yesterday, which of these particular types, oh yeah, I was making sure I get the references. Which of these particular workloads do we use for stateless apps, by the way? Anyone remember? We know it wasn't replica sets and replication controllers because what do replica sets control, by the way? Replication controllers is the old term. What do replica sets control? In regards to our stateless app. In other words, if we go back to our drawing, how many replicas of my fabulous version 2 app do I have? Got 3, right? So I have a replica set in here that defines 3 replicas, right? As part of my what? So there's a thing in here that we're using to deploy my fabulous app. Which of these things under workloads am I using? Because it's not cron jobs, because cron jobs are just jobs that run at a certain time interval, right? It's not batch jobs, which is what jobs are. We're definitely running pods, but remember, pod is the basic unit of what? Oh man, I think I just gave it away. Actually, dang it! You tricked me, right? It's the basic unit of deployment, right? So deployments are the things that's actually what we're running for stateless apps. Now, if in case that wasn't clear when we left yesterday, the reason there are at least 2 deployment types, the deployment that's used for stateless apps. The reason, by the way, deployments are used for stateless apps is because if we go back to our drawing, the names of these pods change all the time. Kubernetes will kill them and start them back up and move them around. And let me make that like sound a little less chaotic than it does. It's not like it's just sitting there like moving things around just to move things around. If there's a failure or some other kind of capacity problem, then it will drop the container and start it up somewhere else because you've told it it's a stateless container, so it doesn't matter. This is a deployment type. It's a deployment workload type. So if we look at our dashboard, we're using deployments to deploy our stateless apps that are here. If this has a database attached to it, I need different things to happen. I need Kubernetes to manage this differently. I don't want a random name for the pod because if it changes the name every time, isn't it going to be hard for me to find my database? It's going to be hard for me to find my database if the name of the pod changes every single time. Now, this is what service discovery is for, by the way, but this is one of the big differences between deployments and stateful sets is that they're defined the same. It's a YAML file that has a bunch of definitions in it. They actually can both have persistent storage, and that's defined the same. But here's the difference between stateful sets and deployments, is that stateful sets keep the same name for the pods. The pods are named the same. And by the way, it's usually the name of the deployment and a number, right? So if we look at CI/CD Jenkins, by the way, see this? See where it says CI/CD Jenkins 0 on my screen? If I start a second one, by the way, it's going to say CI/CD Jenkins 1. If I start another one, it's going to say CI/CD Jenkins 2. It's going to keep adding a number. Why? Because, and by the way, if that pod gets killed, if CI/CD Jenkins 0 gets killed, it's going to start a new one, and the name is going to be CI/CD Jenkins 0. That way I can always find my data, right? Because if this was a MySQL database, you can't just willy-nilly add instances to them. There's no such thing as a MySQL cluster unless you do something advanced, right? So stateful sets maintain a persistent name for all of its deployments. If I go look at this deployment, by the way, and I look at Nginx and I go look at the number of pods, that's funny. Let's go look at the pods. Look at these names. Look at the Nginx names. These are all random, like they're like random hashes, right? By the way, if I kill this one and start it up, it's going to come up with another random name. That's going to be really hard to track when I need to link an application to a data store. So to clarify that, these little guys in red, these are deployment objects. They are done by deployments, by this particular deployment object inside of Kubernetes. Now, because I'm adding a data store, right? Because here's my version 1 database. And let's say I decided that, I'm gonna take this whole thing. I'm gonna replicate it because I need a whole new set of pods, but I need these pods basically to have a database on them. So this is my, let's say version 2 DB, right? And so now what's happened is that I've now created a new pod set, and this is going to be now my version 2 database. And we'll change the color of that just to make sure that it's a little more consistent. Oof, that's a horrible color. Let's use something bright. Oh yeah, there, something offensive, orange. Perfect. All right. And then I'm just going to change this color just for giggles, right? Now what's happened is I've got storage attached to this system, right? Because in order for this to work, I need storage attached to these boxes. Okay. Now we've just complicated things. All right, so tell me what happens, by the way, if this storage is local to this box and this box goes away, what happens to the storage? What happens to the storage? It's gone, right? It's gone. Good for long. It's gone, right? It's deleted. If the host is gone, it has, and I'm using local disk for storage. So to say this, just to make sure this is up front, is that there are a couple of requirements for you to actually have storage available in Kubernetes, because you're not using local storage in Kubernetes. I'm just going to tell you that right now. It's not going to happen, right? What's going to happen is that you actually have to have a separate storage system. We'll pull all this off. You actually have to have a separate storage system. There actually needs to be, really, I cannot copy to save my life. All right, there needs to actually be a separate system that is providing storage, over here. Let's bring this to the front. Oh, you're not going to bring it front? Yeah, there we go. All right, there needs to be a separate storage system. By the way, there are actually tons of services that provide storage. This could be NFS. This could be an iSCSI volume. iSCSI, by the way, is just a way of attaching network disk drives across the network. That's all it is, right? But this is a storage system, and this storage system is required. And notice that this storage system is external from Kubernetes. So just as the load balancer that I was referring to before, when someone was asking me about load balancing, just as the load balancer could be external, right? Because I said it was an external object. If it's on AWS, this could be an external load balancer service, right? This has to be an external storage service, meaning it must be separate from the cluster itself. Now, could you start another Kubernetes cluster and put something like Rook or Ceph or something else on there and have it offer storage to these pods? Absolutely, you could do that. But that's a requirement in order for this storage to function, is that for Kubernetes to actually have a storage class with a storage driver and all of the other things to do persistent volumes and persistent volume claims, remember, those are all terms that we talked about yesterday, that storage system needs to be external from the cluster. Could you cheat and put the storage in the cluster and blah, blah? Sure, you could try that. It's not going to be a production grade system for the most part if you do stuff like that. But you want to externalize this out. Hopefully that makes sense to everybody. All right, so now what happens is that now that I have an external storage system, the first thing I have to do is define what? Out of a persistent volume claim, and a storage class, what's the first thing that has to be defined in order for Kubernetes to know how to hook into the storage system? What's the first thing that we have to define? Storage class has to be defined first. So if we go look at our stuff from yesterday, when we go down here and we look at storage classes, here's a standard storage class. By the way, this is just using Minikube, right? Using the host, right? And it says, hey, by the way, this is just a standard. Here's the driver. I just want you to use this local pieces. That's it. If we go look, by the way, at the actual YAML for this, The provisioner that's using is basically Minikube host path. So it's just using a host off of Minikube. That's it. Just that simple. And by the way, there is a claim against this storage. Why? Because someone actually said, I want an 8 GB storage volume. So someone made a claim against it, right? But go look at persistent volume claims. Jenkins was the one who said, hey, I want an 8 GB volume. Jenkins came with a ticket. That's what a persistent volume claim is. Jenkins came with a ticket and said, you know what? I want 8 GB of storage. And I want 8 GB of storage that looks like this, right? And what happened is that Kubernetes looked at its storage classes and said, oh, you know what? I have that storage. I can get it for you. Let me give you a persistent volume of 8 gigs in size, right? Oh, interesting. Oh, because the other one was released. That's right. By the way, here was another, see this persistent volume of 20 gigs? Because I started another system. I guess it didn't clear out, right? My bad. I didn't clean up all my objects. I did not clean my room properly. Here I requested a 20 GB storage object, right? A persistent volume, but I deleted the container, but the storage is persistent. One of the things with Kubernetes is that you have to be able to lose your entire cluster and the storage has to persist, right? This storage has to persist. So in this particular case, let's say I define my stateful set and I come down here and I've got remote storage running from my external storage system attached to these particular pods. And my version 2 database is able to mount that storage. If those pods go away, the storage stays persistent. Now you can change that policy, by the way, if you want it to delete when it goes, right? But just so you know, like typically when you write persistent data, you typically want to retain it, right? You can control that. But I just want to make sure that's super clear, is that you need to have externalized storage in order to be able to proper storage to Kubernetes from that perspective. So storage class comes first, right? And then what happens is that you need to make a persistent volume claim. Oh, and by the way, you can actually manually define persistent volumes first. Those are usually done by the admin. If you don't want it to be dynamic, if you want to statically, hey, say here's 28 GB drives you can pull from, you could do that as well if you wanted to. Typically though, if they're dynamic, what happens is that you make a persistent volume claim, it talks to the storage class, and then you get a persistent volume in return. By the way, since these are stateful set pods in green, because they're running stateful applications, in this case, MySQL, the pod name is going to stay the same. We saw this when we were looking at the Jenkins dashboard, because if I look at the stateful set in the dashboard and I look at these pods, this particular pod ends with a 0. The next pod is going to end with a 2. The next pod is going to end with a 3, right? And so if I come in here and modify this, and let's say I want to modify the, oh, there's a lot of interesting, cool stuff in here. I forgot. That's why I was peeling this back to begin with. If I decide I want to up the replicas to, that's 12. Let's not do that. Let's do 3. Actually, you know what? Let's just do 2. What will happen is that it shows that one's running, one's pending, and 2 are desired. But look what it did. See this name? Just gave it a 1 on the end. That's it. It didn't give it some one long random hash. Here's the catch, by the way, and this is something to think about. This limitation only really exists with RDBMSs. So this is MS SQL, Oracle, MariaDB, MySQL, Postgres. I'm sure there's others. For some reason, my brain's not pulling those up. Your traditional structured SQL databases, you don't just add nodes to those systems and all of a sudden they scale out. And this requires knowledge of the databases. This has nothing to do with Kubernetes. This has little to nothing to do with the issues with containers, right? This is a problem because of the way the technology works, the underlying application, not because of Kubernetes, right? The issue here is that those systems don't cluster. You can jury rig them to cluster, but by default, they don't cluster. So adding more containers / pods, making copies of these is not a healthy idea, because if we go back to our picture, the first one that gets created is the read-write primary. Everyone that gets created after is most likely a reader, but it cannot write. How many of you dealt with RDBMSs before of any flavor and type? MS SQL, Oracle, Postgres, any of those, right? So you know that there's one of them that's king, and that one is the king, right? It's the reader and the writer, and it is the system of authority for the database. So if I add a second and a third copy, like you see me doing down here, those are going to be read-only replicas. They can't be read-write replicas, because in RDBMS databases, there can be only one. It's like the Highlander rule. There's going to be only one, right? By the way, if this was Elasticsearch or MongoDB or Cassandra or any of the, it could be Neo4j. If it was any of the NoSQL systems, the NoSQL systems don't care for the most part, right? In Elasticsearch in particular, I can add as many nodes as I want to, and as many nodes as I add, they will adapt to become read and write primary. Like they're just part of the cluster. So this limitation around having to be very mindful of data applies to all databases of all types in relation to Kubernetes. But in particular, it's much harder with an RDBMS technology. So I just want to make sure that's super upfront. Regardless, if you have to persist information, you're going to be using this particular stateful set workload type. You're not going to be using deployments. You're going to be using stateful sets. I hope that's super clear. Good, because that's what we talked about yesterday, but we didn't really peel that back a little bit. And I just want to make sure that visually this makes sense.
So do people tend to use like, I mean, I guess it depends on what you're creating or what you're designing, but do people tend to use just like one big database, like one big relational database, or do they tend to use, is there like a cloud alternative that people have adopted that scales? And if you're designing new applications, you design to that instead of designing to like a relational database.
I can really only speak to what's happening in cloud, because most of my work involves either migrating data centers to the cloud or is pure cloud. So any of the cloud providers. Here's what's happening. This is a little silly, but it's what's happening. So let's say that this big guy up here in bright, wow, that is a bright red. Let's say that guy is the database or like a database engine, because they can have multiple databases inside of it for a bunch of these pods, these little red pods down here. What will happen is that this will actually run in Amazon, so they won't run it actually in the cluster. So what will happen is that all of this green stuff will go away. They won't even run they won't run MySQL, for example, inside the cluster. They'll run MySQL out here on this little red guy, right? And that's what they'll do in order to keep state out of the cluster and make the cluster like very scalable and not have to worry about managing the database. And so what they'll do is they'll run multiple copies of this, by the way. So for example, they might have like 15, they might have a bunch of tiny little RDS databases. The RDS is a service inside of Amazon. They'll have a managed, yeah. So Tom, that's it. They'll have a managed SQL server. And so what will happen is that this set of pods will talk to this database. Another set of pods, if there was like a duplicate set, would talk to the second database. The reason is that we no longer are in the world because of microservices where we have big honking databases. What's happening now is that because of microservices, every type of service, so if it's like the credit card service, has a database. If it's the customer profile service, it has a database. If it's the inventory management service, it has a database. And so we're now in this world where the databases are smaller and more numerous. And so they're relying on managed services now. Yeah, I know, it's just like that. Yeah, and it's funny you make that gesture, because with that complexity obviously becomes like it's a little bit more money for Amazon, right? As well. So it's not, but just to say this, like having done a bunch of monolithic to microservice translations to Kubernetes on the cloud, it actually ends up being cheaper for them, because they're either really bad at it and they're already taking outages because they can't keep things up, which is surprisingly common, right? Or two, their operational costs were starting to already go through the roof because they were paying third parties and doing licensing and all that goes away with AWS. You don't, you just, they do all the licensing, so you just let them handle it. So that's the most common way that you see them externalizing databases. If they are sticking databases inside of their systems, and by the way, I see your question, Tom, so I'm definitely gonna answer it. What will happen is that they will, they'll run the databases down here in the blue, but they'll actually put them on a separate cluster. And then these disks, this external storage is actually EBS, which is Elastic Block Store in AWS, or if it's EFS. So they don't have to worry about managing disks, making uptime available, all the other stuff. AWS is handling it for them. So they're using basically this as a managed disk service. So this now becomes yet another external thing. Running Kubernetes on the cloud is like easily 10 times easier than running it in your own data center. Easily. Because all of these services that you need, like DNS and block storage and networking consistency and firewalling and tracing and all that stuff, it all just runs inside the managed provider. So Tom, you asked an interesting question. You said, is it common for it to use S3 for stateful data? It's very common. So you may remember one of the workload types, for example, is jobs. These are batch jobs, right? So don't think of like MapReduce style batch jobs where you want to distribute a job, like the calculations across all the nodes in a cluster. That kind of job typically writes to S3, because what it will do is it'll write to a file or it'll pin to a file once it finishes its job. It's like a checkpoint. It's like, I just finished my calculation here. I just finished my calculation here. And so the stateless pods are writing their data out to S3 because there's a bunch of them and they're all writing simultaneously, right? And it's a tiny little chunk of data. It's not structured data. It's not NoSQL. It's not, it's not, but it might be Arlo or Parquet or some other structured file format. And they're just writing to a file continuously or writing separate files. S3 is great when you need to en masse write a bunch of files to a file system. But just to say this, S3 is not really a file system. So your application needs to be able to, from an API perspective, write into S3. So that's the most common uses for S3 is tiny little data writes that you're doing en masse across a large data set that you're trying to put inside a system. S3 is awesome for that. Log files, by the way, are great for S3. But like session state, like stuff that's really live, like leaderboards and stuff like that, S3 is not good for that. S3 does not respond in like single digit millisecond response time. So it's not good for any kind of real-time use case. Okay. I think at this point, oh, the only other thing we didn't talk about, hold on, wait. There were two other things we didn't talk about. Sorry. We're almost there. We're almost done with our review. This went a little bit longer than expected, but I think we've hopefully cemented the ideas in people's heads.
I have one more question about the database before we move on.
Well, you can ask all the questions you want. You get one more. You can get 50 if you want to. Go ahead.
So with the concept of the multiple mini databases talking to different pods, does that cause a lot of redundant data in the databases? Or is there a way to like search multiple databases through joins?
That's a good question. And I'm trying to figure out how to explain that because where it doesn't apply. Because here's the thing. Let's take this, for example. I'm going to make these smaller so we can actually get these spread out. So let's say that you've got a set of systems, and let me pull these pods out. Here we go. All right, this will make this easier. Okay, so let's say that you've got a series of pods. In this case, we pulled the containers out of the pods, but you kind of get the idea, right?
Mm-hmm.
So over on this right-hand side, what happens is we've got this whole set of systems, and this is a microservice. Let's use green because that's a loud and offensive color. We'll never forget it, right? All right, so we've got this service, and this service actually handles, let's just say it just does credit cards. That's all this service does, right? And all of a sudden, Katie posted this on Reddit, and the next thing you know, it's like 10 times as popular as it was. I'm not saying that Katie's on Reddit. I'm just speculating. Just ignore me, Katie. And so what happens is that we've added 6 more pods to our system. And so this thing can no longer handle the load. But in an RDBMS system, you only have one database that can control the consistency of the data set, right?
Mhm.
So what happens is like, if this is a MySQL, then this is the primary guy. But in order to scale, what we've done is we're going to add readers, right? They're the same size, but these guys can only provide read access to these pods.
Okay.
So what happens is that this guy is still king. This guy at the top, he is still the primary controller of the basically veracity, the state, the acidity, right? Remember acidity, atomicity, and like all this idempotency, consistency, durability of the data. This guy is still the primary owner of the data. And these guys are just like secondaries who can provide out read information, but they cannot accept writes.
Okay.
So what happens is that you are duplicating the data, but you're also duplicating the engine that provides the data. So all of these guys might come over here to get their read information, and when they write, they'll come over here.
Okay. And then there's less traffic for the writes, so it can handle it
Exactly.
better.
Yeah, and
So-
so and by the way, as long as read traffic is your problem, you can add as many readers as you want. But if write traffic is your problem, you're going to have a problem.
Okay. So follow-up question. So let's say we had a whole different set of pods for the user login information, so username and password. If we want to tie in the username to a particular credit card, will we have to also store the username information in V1 database as well
Nope.
and duplicate that?
That's a great
Okay.
question, but that is a microservices question, just so we're clear about what we're talking about, because that's a design question about how that would work. So here's how this would function. So let's say that these yellow ones are now these are handling customer profile, but you need the linkage back to like, hey, this customer, what credit cards do they have on file? What would happen is that while the data on customer profile information would be stored with the customer profile service, which is these guys in yellow,
Mhm.
what would end up happening is that if this guy, this first service needed credit card information, what they would do is that they would actually come back and talk to this service. They would get the information would get returned, and it would come back to the system.
Okay.
So there'd be no linkage. First of all, this service could not talk to the data. Hold on. What just happened there? This service could not talk to the database. So yellow could not talk to green's database. Yellow would have to talk to the service.
Okay.
But that's a microservices restriction, right? Because in microservices, the only way these microservices can talk to each other is through APIs.
Okay.
So you would never allow green to get access to yellow's database, and you would never allow yellow to get access to green's database. They could only talk through this programming interface up here.
Okay. That makes
Yeah.
sense.
Yeah. And then that way there's no duplication of data, right? Don't get me wrong. This guy might like pull the data and like store a cached copy of it and mark it as temporary inside the system, but it would just be temporary copy. But you wouldn't necessarily be duplicating data, because this green database up top is the system of record on credit card information. These transactions, by the way, take under 10 milliseconds.
Okay.
So they're super fast. This is, by the way, how almost all the digital natives, Netflix, Facebook, you name them, this is how they scale, right? Is they create these tiny little distributed systems that are operating across, 40 gigabit networks, 100 gigabit networks, right? That are all executing transactions at microseconds. And if this guy gets overwhelmed, if this like first system gets overwhelmed, they just horizontally scale. They just add more workhorses to get that to function. But I want to add one little caveat, and this is the last little piece, and then we'll switch over to talk about daemon sets and config maps and secrets, because these are the last pieces for review, right? Is that these limitations that I just talked about, they only exist in relation to RDBMSs, which is only one type of data store, right? The other type of data store, you know how people were joking like years ago about how MongoDB was web scale? Did anyone ever see that video? It's like MongoDB is the secret sauce that makes the internet go. If you've never seen that, it's actually kind of funny. But MongoDB is actually legitimately cool. Like, it's actually a cool technology, right? It's not, nothing's a panacea. But that's an example of a NoSQL data store. Here's the cool thing about a NoSQL data store, just to pivot this around, right? This whole thing about having one primary doesn't exist in a NoSQL data store. In a NoSQL data store, you can have multiple primaries. And by the way, every time you add a node, it can actually also become another primary. And you might be saying to me, Michael, that doesn't make any sense. What do you mean? What do you mean that if I add another one, this guy can accept read and writes, this guy can accept read and writes for the green set, this guy can accept read and writes, this guy can accept read and writes, and this guy can accept read and writes for the yellow data set. All of these are stateful sets inside Kubernetes, but you're telling me that the technology will allow this guy to read and write into any of these data stores? That's how this works? Yes, that's how it works. Here's the cost of that. These guys can accept writes and they will actually send those writes out to their peers, right? But the cost of that is lag, is it what they call eventual consistency. Meaning that if I write to this second yellow database, it might take a few seconds or milliseconds to actually replicate that write out to the other systems. So if someone comes in and does a read, you may not be getting the latest data on this system if this guy just got an update on the second database. So just something to keep in mind, eventual consistency is usually acceptable to most applications because you don't care if it's off, right? But let me ask you this. If I go check my banking statement and it's off by that would probably bother me, right? Hey, you told me I had, $10,000 in the bank and I only have 5. It's like, that would probably bother me, right? A little bit, just as an example. So there are certain use cases where NoSQL doesn't work. For most of us, NoSQL works great. And by the way, you can actually force most NoSQL databases to be strongly consistent. But again, this is a database issue, not a Kubernetes issue. So I don't want to spend too much time on it. Just remember this. If you are trying to persist data inside of Kubernetes, you want to use stateful sets for a variety of reasons. 1, the names will stay the same for your pods. 2, it is purpose built, right, to make sure the DNS name doesn't change and that systems stay affiliated with each other, right? Meaning that pods can stay connected with other pods. That's what stateful sets are for. Deployments are specifically for stateless applications. And even though you can actually configure storage and configure them identically, the fact that your service name will not change with stateful sets make them much easier to use when you need to hook applications in to a data store. That's what stateful sets are really for. Okay. That was the main piece of that. There's some good questions there. Okay, let's talk about config maps and secrets just briefly. And I think that then we can move on to new material, unless people have questions. Okay. Secrets are basically mountable secret information that you can actually put inside of your pods. So for example, let's say that this tiny little blue guy down here, this is a database secret. Make him really tiny to reflect the fact that he's going to be just a small piece of information. And let's make him a bright little blue. Okay. So this is a secret that can be mounted inside as a file inside of my pod. So in my container, inside my pod in particular, and it looks like a file, like it's part of the file system. And I can just read that thing out. And that's where I can get the username and password, right? It can be hashed and all kinds of stuff can be done to it so that even a human can't read it without having to decrypt it or do some variation thereof. But that's common. By the way, you can also, have an external. Let's shrink this down. You can have an external secret service as well. If you don't want to use secrets inside of your Kubernetes cluster, you can actually externalize this to a secrets vault. You can use AWS as the secrets manager. You could use HashiCorp's vault. You can actually link Kubernetes up with an external vault so that you don't have to worry about database secrets being stored inside of your etcd database, right? You don't want to do that. That's fine. You can also externalize it. That's also totally cool. But this mounts inside of your file system and can be read by your application, right? By the way, this is also true for config maps. Config maps, basically, like, let's say that I create a config map, and the config map I want to create is the comp file for Nginx, assuming that, hi. So weird. I can actually mount the Nginx comp file with all of its directives, by the way, inside as the comp file at runtime for a pod. So I can control the configuration of these pods that have applications in them. I can actually control that and externalize that into what's called a config map that actually sits inside of etcd. The config map, by the way, is just a configuration mapping. It's just a configuration file. I can mount that as the file that Nginx uses, or MySQL uses, or MongoDB uses, or Etsy password, group, all that stuff. I can mount those files inside the container to make it use those files as for configuration. That's why they're called config maps. But I want to mention that because storage gets mounted, obviously, has the volume. But also config maps and secrets get mounted as well inside of the pod / container in question. The only difference is that secrets contain sensitive data, right? That's usually hashed and encrypted in some form or fashion. But there's tighter like security around secrets than there are around config maps. But all of that does go in the etcd database. Okay.
So, sorry, let me see if I understand correctly. So a config map is essentially data stored in etcd that can be mapped to multiple pods to provide configuration for a service or for a container. Is that accurate? I think that's accurate.
That's
right?
Config maps basically are used to provide configuration information, right? They don't have to just provide configuration information, but that's their primary purpose. That was their intention. Let's go take a look and see if we have any config maps. Here's an interesting config map for Jenkins, right? This is the one, by the way, that basically prevents like setup wizard for Jenkins, because I don't know if you've ever seen the setup wizard for Jenkins, but when you first install Jenkins, it asks you a bunch of questions instead of taking you to the base page. It forces you to answer all these questions, right? So it looks like it's like downloads a bunch of plugins, copy some stuff into Jenkins home for the plugins reference, right? So this is all configuration information that it's mounting inside of the Jenkins container to force it to both set up the plugins in question, but also to force it to not ask me a bunch of questions when I want to log in, right? That's one of the config maps for Jenkins. Here's another config map for Jenkins. Look at this. Oops. You know what? Let's just bring this out in edit mode. Here's a config map. Actually, most of it should be down here. Oh, here's the data. All right, so this is actually a YAML file, right? And then this is everything inside the YAML file. This is Jenkins stuff, by the way. This isn't Kubernetes stuff. This is Jenkins stuff. This is what it's actually putting in the file, including basically setting up a Jenkins admin using a variable that's actually defined somewhere else. The chart, by the way, the Helm chart that I used for this actually has the admin password. It asked me what it wanted to be, right? It has other things like what the Jenkins URL is, plus the Jenkins tunnel, which is for distributed agents, right? I love the URL. That's horrible, right? But these are all just values that are associated with this file. And here's the file in question. Now, this is the definition for the config map, which just contains a bunch of data for Jenkins to use. Who told this config map like where it was gonna, like, how did it get derived? We take a look somewhere in here, right? There's basically a map where it's basically mapping a config map. So, oh, you're not gonna search inside of it. Yeah, that's okay. All right, let's keep going. We're looking for it. Where is it? Ooh, it's gonna be in here. I know you're here, but you're not letting me search. Let's see, chart admin username. Oh, by the way, here's some secrets mounting. That's actually useful, right? It is mounting some secrets. Remember we saw that chart admin username referenced inside the config map before? Just now when we were looking at config map, here's the secrets being mapped, right? So it's actually pulling that variable out. The chart admin password, the chart admin username were both secrets that get mounted according to the Helm chart based on what you put in it. And then that gets referenced in that file that we were just looking at, where it was like, oh, I want you to set the username and the password to what's referenced inside these secrets. Where is, oh, there it is, Jenkins config. So it's volume mounting the Jenkins config. It's mounting it here at var Jenkins config. It obviously is set to read only, so nothing can write to it, right? And if we go back, so this is inside the stateful set, right? This is the stateful set for Jenkins, which is the deployment methodology, right? For Jenkins in this particular case, because Jenkins needs storage. If we go back and look at our config map that we were just looking at, right? This is, it's basically mounting this file in that other file, the stateful set file that we were looking at. If we were look at secrets, let's see, not there. Was it this one? Might have been this one. Let's take a look. There's the release data. Ooh, it's all encoded. That's not going to be fun to look at. Yeah, that's release information. Huh. Maybe it's not here. Let's take a look. Pardon me as I poke around a little bit. Oh, here it is. Okay. So here's the data for the Jenkins admin user, Jenkins admin password. So that's where you would find it basically in the secrets map. So if I needed the raw data, right, it's right here. But this is what's getting mounted, has a file inside the pod. And then what's happening is that the stateful set definitions mounting it in, and then that config file is then pulling those in as variables just so this can be abstracted away. Now I'm the admin on the cluster, so I can go look at this all day long, right? But most of the time, you're going to have users in the cluster who cannot actually see what's going on with their secrets unless they've submitted them, right? For the most part, like you can have that abstracted away from the users of the cluster versus the admins of the cluster. Okay, so I just want to make sure that's super clear. Configs and storage are basically just types of storage. You can mount config maps in having full configuration files that can override your configuration files inside the container/pod and then use those as configuration. You can have secrets that contain information that you can then both import directly or reference as variables inside your configuration files. And then of course you have storage classes and persistent volumes and persistent volume claims, which work together to define the type of storage that you can actually use inside of Kubernetes. That seems like a pretty full review. So Mike, by default, they're in plain text. They can be encoded and encrypted into another format. You just need to have a decryption methodology for that, right? So by default, they are actually in plain text, but if you can submit them encoded in another format. Yeah, you could also, by the way, there's ways to configure etcd to do its own field level encryption, but that can be problematic. You just like that more advanced stuff. My recommendation is submit it as encrypted and have a decryption methodology on the back end for the container. That way, not just anybody can read it. All right. It's 10:15. We took an hour and 50. Well, God, we took longer than that, right? We took longer than that to go through everything, which is good. I hope this was useful. I hope this gave you at least some kind of visual representation of how all these pieces work together. If I further confused you, you should let me know. But hopefully you now have at least a better representation of like how all this works, how this all sits on clusters, right? And how all this kind of works together. Seems like this might be a good time to take a break, but I want to check in first. Does anyone have any questions? No one's hit their quota yet on questions, so you've all got at least 40 or 50 questions left to ask if you want to. Okay. All right. So it's 10:15 by my clock right now. So why don't we take a 20-minute break? Let's come back at 10:35. I'll put a timer up and then we'll pick up with new material. All right. Go back. Let's talk about this for just half a second. Let's see. Here we go. I'm just mentioning I put the reference documentation for how command and entry point interact. There's some complexity here just because basically when entry point and command are both present, command entries act as appendices, if you will, to entry point entries. So like, you know, there's some interesting kind of things that happen when the two are present inside the same thing. Notice, by the way, that that things are being executed as a shell, right? With entry point in what's called a command format or a shell format versus entry point in a basically exec format or shell format. Same over here with command, by the way. But here's the interesting piece. If we look at the like exec format of entry point, which is where things are in quotes and they're basically JSON delineated. Notice that the exec command and P1 command, which were defined over here in this command, are actually suffixed, right, to the actual entries that were actually in the entry point command. So there is some complexity that can happen. You can, by the way, use the -- right, entry point command to override. But if you're overriding the entry point command, then you probably need to just look at your Docker file, right? Because unless it's like troubleshooting or one-off, right? But for the most part, your Docker file should have the actual correct entries for how you want the thing to run initially. If you're troubleshooting or looking for a variant, then you can actually override it. But best practices is just make sure that your Docker file is set up the way you want to. There's some complexity here. So I would say, you know, I would probably just stick with entry point. This is typically what we do out in the wild, is we just stick with entry point and just like add the pieces that we want. But know that when you put command and entry point in the same file, there's going to be some interesting interactions, including the addition of suffixing your command entries after your entry point entries, right? You want to avoid this as much as possible, by the way. Having things run inside of a shell. That I know that can cause issues with like variable substitution, interpolation, and stuff like that. But trust me, it's not worth it, because when things are running into a subshell, that becomes PID1, right? The shell becomes PID1. You don't want that, right? You either want a supervisor or the actual application itself to actually be PID1, which means it's the primary thing running inside the system, and it's the thing that Docker and therefore Kubernetes is going to watch inside the container to make sure the containers is working. So more information there. Let's see. I did actually share out the drawing. I actually shared it out, by the way, so it's editable. So if someone needs to go and change things and mess it up or do whatever, totally fine in Google Docs. So you can go in and edit as you see, like move it around as you see fit. Any questions, let me know. This may not be useful, very useful, except for those who are there, but in case you need to like stage scenarios or do anything like that, it's there in case you want to mess with it. All right. All right, so let's talk about application administration. Talk about these next phases, next sections. Oddly enough, we're on chapter 4 and we've got 2 full days left to cover. So, you know, we're on track actually. Usually the first day takes the first 3 chapters, and then we cover 4 chapters a day for the remainder of the next chapters, give or take, right? Some of this is going to be duplicative. There's no way to get around it, right? Because we've already talked about some of it. We've meandered, we've wandered, but I want to re-expose you to some of the same concepts and see if we can't push them forward. So we might find this particular chapter a little duplicative, but trust me, we're just trying to make sure that you've got like the basics and fundamentals here mastered. So let's talk about, let's take that off. Let's blow that up a little bit. Okay. So installation of Kubernetes, by the way, is a huge topic. If you're in a cloud provider, by the way, which I'm going to show you, I think I'll show you my Kubernetes cluster after lunch. Maybe it might be tomorrow morning, but I'll show you like as I mentioned before, when you set this up in a cloud provider, a bunch of stuff is done for you, because that's the reason we use cloud providers, is because they abstract away things like hosts and networking and all other stuff. It doesn't mean you can't control it. It just means for the most part, you need to worry about it. But I think someone mentioned that they were using microK8s, right? On wasn't like a couple people were mentioning they were using microK8s for their like cluster setup, which is by Canonical, the makers of Ubuntu. It's funny because a buddy of mine, I think, used microK8s to actually put a Raspberry Pi cluster together using microK8s as the underlying, because Ubuntu runs natively on runs on Raspberry Pi, and so he was using that to create a microK8s cluster for his little. I don't know if you know this, but they now make chassis for Raspberry Pis that you can buy on Amazon that allow you to just slot them in, so you can literally hook them together and then hook them to a network switch, and then you get a portable Raspberry Pi Kubernetes cluster. And there's tons of tutorials, by the way, if you haven't seen that, which is actually pretty awesome if you need a portable K8s cluster. Probably more useful post and pre-quarantine, when we actually went to meetups and showed people how to run stuff locally. But it's a great, if you're worried about network connectivity or you've got firewalls blocking, you can actually take your cluster with you. So he's convinced me that I probably need to do this as soon as everybody's reached a certain level of vaccination. The main thing, though, to know here is that there is such a large variety, everything from COPS. And by the way, if you hear me use anything that sounds like a C, it's a K, okay? COPS, KubeAdmin, KubeSpray. There's tons of tools for installing Kubernetes. Minikube is probably one of the most popular ways by which we provide localized environments. I would suspect that microK8s is also pretty popular for that. microK8s is the one that was from Canonical. But the installation, the best way to learn the installation process is that Kubernetes the Hard Way link that I shared with you by Kelsey Hightower. That's considered a rite of passage for most people who decide to get into operating Kubernetes, because it will teach you how to manually build your own cluster. And once you do that, you will start to appreciate what all of these installers do for you, because it's very interesting. So most of this with Minikube, you're already familiar with if you're using Minikube startups, right? But you've probably seen me do things that you were like, dashboard, for example. You can also, by the way, call a service. So you can actually invoke a service and have it kick out a URL. But most of this is redundant because like we'll speak to this and cover this inside labs, right? Now, that being said, in addition to having access to a cluster of some type, whether it's microK8s or Minikube or whatnot. And by the way, Minikube is available via Brew, Chocolatey. You can download it, install it locally. You can run it, by the way, Minikube has just a bunch of Docker containers, or you can install it on VirtualBox. I think the conversation with, I think it was Greg, like you and I were talking about like nested virtualization and hypervisors and, all WSL and all that stuff. I'm not a big fan because I tried WSL before, but it actually has me thinking about going to revisit it, because Vagrant, by the way, has enhanced their capability of interacting with the Hyper-V. So I'm probably going to go revisit that, because Minikube is getting a little long in the tooth, frankly. It's been around for a while, and it's got active development on it, but I don't know how super popular it is. That being said, there's a couple of different ways to interact with a cluster once you've got one stood up. But the scoping of doing a full install is a little bit beyond the scope of this class. We do actually have some Katacoda labs that involve using KubeAdmin to add nodes and initialize, which we will talk about. But I'm not going to necessarily go into all the different variations of installing Kubernetes. The main thing you need to know is that you need an operating system that supports containerization, and Kubernetes sits on top of the operating system. That's the basic components and structure. What operating systems do to support? Pretty much any modern Linux distribution. If you want to run Kubernetes for Windows, I'm just going to tell you right now, don't run 2016 Windows. You need to run 2019 and above. I know they say they can run 2016. It's not a fun experience. Just stick with Windows 2019 if you decide to go that route. Now, let's see. The kubectl command line interface, other than the API and probably other than dashboard, are the primary ways in which we interact with Kubernetes. Obviously, if you've run a cluster of any type and you set up kubectl, there's probably a couple things to be aware of, right? Is that obviously help is going to be your friend. And then things like cluster info, create, describe, node, run, get is like the general list. These are like general commands, and there's tons of really great cheat sheets for this. Now, when I'm running kubectl, an example, so I'm kind of curious where this is. Yeah, it's under Chocolatey. Good. If I'm running kubectl as an example, I might be giving away all my secrets here. Yeah, here in a second. Yeah, we're still recording. Good. Okay. If I go into the kube directory, right? Kube directory is where all my stuff is, right? Including the config and whatnot. This is going to be a security nightmare. If I display what's in config, by the way, you'll actually have keys to my Kubernetes cluster, but don't worry. We're recording and I'll change it after we get done, right? So, oh, that's right. I forgot. It's not here. So here, by the way, is where all the different potential contexts are configured for kube, right? For kubectl in particular, right? Now, notice the main context that I have active right now is just Minikube. How can you tell? Well, one, the only cluster that's defined right now is the Minikube cluster. I don't have anything else defined. Notice that it's got the server linkage, right, for A443. The provider in question, all this, and then it's got a bunch of contexts. It's got one context, right? In this particular case, it's the Minikube cluster. If I add my EKS cluster or my AKS clusters in here, you'll see other like information for clusters and contexts, right? And then it'll basically show the current context that's been set. Notice this interesting. There's a little bit of like a config preference set up here, including the particular client keys and the CRT keys, right? Those are basically the authentication pieces to get basically into, right, the Minikube cluster. So there's some security information, right? By the way, there could be a token in here also, right? Sometimes you can dump tokens in here to get information, right? So this is where the primary configuration information is for kubectl. Obviously, the rest of this is just caching of various types, right? Most of the time, we don't mess with these. We might clear them out if there's a problem, right? But for the most part, we don't mess with this. The main file that we might mess with is the config file. That's it, inside.kube. And if you've had to set context or do any of that, which by the way, you can do off the command line, you've probably been in this directory before and messed with it. Okay, now, what does kubectl cluster info tell us? Well, as you suspect, basically just gives us some basic information about our cluster, right? One of my favorite commands, by the way, oh, and by the way, it does show you if you want to dump all the information about the cluster information, if you want to debug and diagnose problems. One of my favorite commands is kube API resources. Let me pipe that to the left so you can see that differently. By the way, what this does is it gives you all the short names that you can use for stuff inside Kubernetes. Now, I have forced myself not to use aliases and not to type in short names, which I usually do as I optimize my usage of a particular command line tool over time, so I can keep things big. But you will definitely, for things that have a shorthand, you'll start using the shorthand. So instead of typing services, for example, you'll type SVC, right? Instead of typing, deployments or replica controllers, you probably wouldn't type replica sets, you would type, right? And instead of typing deployments, you would type deploy. Instead of typing daemon sets, you would type in DS, right? But stateful sets is STS. Like, this is the full list of shorthands. The other thing also, though, is that it does list the API version. Why is that important? Right? That's important because you actually at the top of most files, when you list the API version, you have to list like version 1 or apps/version 1, or if you're doing like access reviews or batch files, you'll have to submit that as well. So this actually gives you a full list of everything that's there, right? So kubectl API resources. Should be the same across any vanilla installation. Any CNCF compliant installation of Kubernetes should have this. But just also know that if someone has added custom resource definitions, they've extended the objects, they've added objects into your Kubernetes cluster, which, by the way, obviously only someone with permissions can do. It's not like any user can just extend it. If you've got a new API set or a new object in here, it will actually show up here as well, right? So if someone adds an operator for like MySQL, right, that'll show up here. If they extend it and add AWS resources in there, or Azure resources, or Google resources, if, like, for example, there's an AWS controller, like there's a Kubernetes controller for AWS that you can install that will allow you to control your entire AWS account from Kubernetes. Now, again, permissions are assumed, right? That shows up, by the way, as an API endpoint here that you can manipulate. Let's see, Greg, let's see. Are the API versions listed there, the APIs exposed via the master API servers? Yes. It's basically, it queries the server and says, hey, what's available against the API server? Like, tell me everything that you've got. What objects can I talk to? What are the endpoints I can interact with, right? Notice, by the way, that it'll tell you which of these are namespace. And if you want to put them in your YAML file, notice it'll tell you the kind. Remember kind? We just saw kind actually in our config file. But when we define the kind, we can actually follow it and say, look, most of them are intuitive, by the way, but notice like persistent volume claim. Let's see, what is one that's not intuitive? Oh, batch jobs. So like if, like batch jobs, oddly enough, look at this. It's like the API has batch version 1, but it's just referred to as a job, just like this is referred to as a job, like in terms of just standard parlance. Right, but sometimes like there's a slight mismatch, but for the most part, they actually match what you think. Stateful sets is stateful set. Replica set is replica set. Just notice, like, for example, the spelling of it, right? So this is how it needs to be spelled in your YAML file if you want to do a definition of it. So this API resources command is very valuable. Basically, it lets you know exactly what you need to stick in from a kind standpoint, what version of the API you might need to define. And by the way, notice that this says apps version 1, this has API registration, this has authorization. These do actually change depending on the object that you're putting in your YAML files. So you can get that information here. And then whether or not it can be namespaced or not, right? That's actually captured here as well, right? So I love that command. It's particularly useful when someone's like made a custom Kubernetes cluster. They modified it in some form or fashion. All right. Yes, tab completion. Yeah, which you can add by running the kubectl command. Actually, when I show you my cluster later, I'll show you how to add tab completion and all those pieces to it. That way you can see the objects. I think that tab completion would work based on standard objects. If there's new objects added to the system, you think you need to add them to the set, but that's a mystery actually. All right, things like create or apply, right? When you want to apply a file, describing a particular node, right? Obviously that's easy to do. Running an image, we've seen, getting nodes, getting everything. You can get everything. And by the way, you can comma separate these things together. So if I want to see basically deployments and services, right? I can just do that. Tom, so you can run create on the command line if you want to create something and you're not using a YAML file, right? Apply pretty much requires the -f option to like apply a YAML file. So create can just create objects without a YAML file. Create can use both object definition on the command line and it can use a YAML file. Apply can only use a YAML file. At least that's the only way I've ever used it. Whether that's the technical limitation, I don't know. But apply is I've only ever applied to YAML files or files I pulled across the web. So create will create an object without a YAML file. You can actually define the object definition pieces right there. By the way, if you leave pieces out, Kubernetes will make assumptions for you about how you want to create the object. So if you don't define if you don't define the optional parameters, it will make some assumptions for you about like like what to create. What those are, by the way, I don't have those memorized. Like you need to go take a look at the object you created. General rule of thumb, create objects through files. Not only can you then get infrastructure as code, right, by checking these into a repo, right, and have them be parsed and see what's been run, right? But then you can actually share them out. So that's also very nice. So when you run any of the commands, if you want to run like multiple objects, like a deployment, a service, for example, you can just separate it out. Right, it's just that simple. If I wanted to add pods in here, it's just going to list everything in one fell swoop. So just know that you can actually define things by comma separated objects. Let's see. And we're like, we use Docker inspect, I think, when we want to dive into something. What's the word when we want to like peel out the detail on a particular object? So let's say I get nodes, right? If I wanted, I can describe a node. Yeah. Minikube. That gave me more information than I probably wanted. But describe basically will tell you things like, hi, what's going on with this system, right? How big is it? How many CPUs does it have? What's running on it? What namespace is it running on? What's the operating system? What's the pod sitter, right? What's the pod sitter address? Does it have an assigned IP address? What is that? What's the status? Does it have sufficient memory? Does it have any disk pressure? Does it have sufficient available PIDs for CPU cycles? Is the kubelet ready on the system, right? Here's all the various labels, right? By the way, which of these are required, labels or annotations? Yeah, labels for the most part are required. Annotations are remarkably useful, and they're not necessarily required. Kubernetes will write them out as it sees fit. So describe, right? Let's see, Tommy asked a question. Is there a way to hook or apply create to automatically put the YAML into a repo? No, you can make it so that Kubernetes can watch a repo, particularly if like OpenShift will do that like out of the box. OpenShift will read a repo out of the box, but you can make it so it watches a repo, and if a repo gets changed, you need to do a little bit of orchestration to get that to function. But I don't know that I have ever done it that way where I'm like, oh, if someone applies it, can I automatically pop it out into a repo? That would be nice, actually, if it did that automatically. It was like, hey, here's my configuration. I'm writing out to a repo. Someone just added an object. I just updated the repo. That would be awesome, actually. That would be kind of GitOps at its finest. I think Argo CD has some capabilities like that, but I haven't done that level of GitOps just yet. Argo CD is a like GitOps build tool. You're probably familiar with it. If you later on, I'm going to show you some labs that you can use to actually dive into Kubernetes, particularly on AWS a little bit more. These are free labs. They're like public unlisted labs that AWS and others like publish out. You will have to run an EKS cluster in order to do this, but it's still like Kubernetes. It's still applicable. They have an Argo CD lab where they actually obviously read from a repo, but I think Argo has the ability to read a Kubernetes cluster and write objects out. So that'd be interesting to research. Okay. Why have you done that, by the way? I maybe I should ask you, have you seen that in action? Has anyone you've seen done that, Tom? There's so much to know.
No, I
Yeah.
just thought it would be really good to see all the YAML that's being applied or created. Like, it seems valuable from a forensics standpoint.
Yeah, that would be awesome, actually. Sounds like you've got a new business model. Yeah, that would solve a lot of problems, frankly. So, yeah, none that I'm aware of. Okay, so let's talk. So we talked about kubectl just a little bit. There's obviously a huge swath or piece there. Just know that the tool exists. It basically you can get, you can create, you can apply, you can basically manipulate almost everything inside of Kubernetes with kubectl. The other thing to note though is that when you want to access the proxy, you actually have to connect to the namespace, and you can actually curl directly into the local host, assuming, by the way, that you have like the necessarily permissions to do so, right? And you actually hit the API endpoint directly. Actually, it's so funny. I accidentally clicked on it. My system like popped it up and said, "Hey, can I actually talk to this endpoint?" So you do need to replace it with an appropriate like host IP address and port number, depending on what you're trying to access. But if you actually set kubectl proxy, what's happening is that you're actually setting this as the loopback for the system. So for example, if I just went back to my browser, and you actually saw this when I was actually doing kubectl, sorry, not kubectl, Minikube dashboard. With Minikube dashboard, notice that you actually saw it create a local loopback into the, it's like looping back. Kube proxy is attaching to my command line and basically saying, look, port 52315 on local loopback now is actually going to redirect into the endpoint on Minikube. And what do you get as a result? You get the dashboard. See that URL? I know it's really tiny, right? But it's the same URL that was down here before, right? So kubectl proxy allows you to hook your system up, like your local command line terminal and your network stack, to what's going on inside your Kubernetes cluster. So you can actually connect to your cluster as long as your kubectl command can connect. You can actually connect your local network stack out to your remote cluster. Here's another like manual run of this. Right? So if I then open another Git bash, let's blow that up. We got a second terminal here, and we look, like for example, this one's just hitting /API/version1/services/Kubernetes, right? So first of all, let's see if curl is here. Hey, it is here, right? Whoa, what happened there? Did I just type in the wrong thing? Nope, I type in the wrong thing. Kubernetes looks right. Did I make a mistake there? Let's see if it needs to be in the same command window. Nope, should work actually. I got a 404 though, right? Right, I get a 404, so it's probably like, who are you, right? What are you doing exactly? Why are you trying to get in here and do this thing, right? So, okay. I'm gonna assume that's an authentication problem. Let's see if I can run that. I forgot an S, that's fine. Yeah, must be having some kind of authentication problem. Weird. All right. Well, maybe I need to submit the token on the wire or do some kind of certificate submission. For whatever reason, it's not working. But okay, fair enough. The demo gods are always kind. But you could actually, with the like proper authentication, you could actually access the system in question. So you should be able to curl directly. Then we know like this kind of thing works because you saw me running a function earlier against like Docker Hub and it worked fine, right? So I'm going to assume that this either some kind of a resource and addressing problem or that there's some kind of authorization problem. but because this URL should be valid. But we know that kubectl proxy works because I've been running Minikube all day long with the dashboard, and you've seen the proxy command take over at that point in time. So failed demo. That's fine. We're going to spend time troubleshooting why that's not working. So this is where this has been running and then popping directly in. If you run Cloud9 or any other kind of like cloud-based IDE, it'll actually run kubectl locally as well and allow you to local loop back that particular IP address into the system in question. So, that's going to be interesting. That's going to bug me. Why didn't curl work? All right. Now, the other thing that you've seen.
I dropped a note in chat. You can try the same URL, but without the Kubernetes on the end and at least see something working.
Oh, was it, is Kubernetes somehow invalid?
Yeah, I think that name maybe isn't mapping exactly the same way. But you can like look at other services.
Oh, I see. It was actually explicitly looking for the Kubernetes service, which is why it wasn't functioning. Okay. I wasn't sure. I didn't have that memorized. I wasn't sure if it was a generic URL for like listing all services inside the system. Okay, well, that works. So that's definitely not an authentication problem. Thank you, by the way, for the correction. There, by the way, it's returning all the services, and there are quite a few actually on the system. Thank you. All right. And then if we looked at namespaces, this is the default namespace against pods. We could see that function as well. So. And so this is listing all the pods, their status. Obviously, this is a lot of raw JSON to deal with. So you'd have to pipe it to JQ or do some kind of parsing in order to find the pieces that you were looking for. But that's a raw hit against the system. Good. Okay. So you can actually hit the API directly. You can use kubectl, or the other way that you've seen me use quite a bit is the Kubernetes dashboard. Right. So you've seen me hit the dashboard quite a bit to show visual access to all the different like sections and segments. Everything we've gone through, everything from stateful sets to deployments. We haven't gone through like daemon sets or jobs or cron jobs or anything like that. But you've seen storage classes, their persistent volume claims and the persistent volume, as well as the config maps and the secret setup. Right. The create button in the upper right hand corner does allow you to create assets. Most of the time, it's going to ask you for a YAML file to make that definition. But the dashboard's a great way to validate what's inside your cluster if you need a visual representation of what's happening. The Kubernetes dashboard is actually part of the official CNCF project for Kubernetes. So so if you look inside the Kubernetes code base, there is, or sorry, the Kubernetes official repo inside of GitHub, you can actually find the dashboard linkage, right? Which includes the general purpose dashboard code. Installing, by the way, is just as simple as basically applying the particular specific recommendation for your particular cluster. It is remarkably backwards compatible. So good. Your kubectl command, by the way, will have to have like prior access and context in order to get hooked into this. So there we go. All right. Okay. So to like when you're basically understanding how objects function inside the system, we actually saw our visual representation of this earlier. We were running through this, right? Which is that, let's see, where is our visual? Is it here? Here it is, right? So obviously, when in this particular case, you've got a cluster that contains nodes, right? You've got a master, you've got application nodes. And so inside each of those, right, the cluster is going to contain nodes. The nodes are going to run pods, in particular the application nodes. The nodes themselves are running pods. pods hold containers, containers hold applications. So we go back to our visual, right? The core of what we're looking for is the app, right? Because remember we had our Java app for our fabulous version 1 and version 2. This is the core of what we're doing. So the application's here. The container for the application runs inside these pods. The pod runs on an application node. The node is part of a cluster, right? So this defines a good hierarchy of objects inside of our cluster. This is significant because deployments are the recommended way to basically manage the creation and scaling of applications, particularly what type of application. When we say that we're talking about deployments as a particular object type inside of Kubernetes, what is the main, what does a deployment cover? What type of application are we looking for? Nothing specific, like not Java, right? Not like MongoDB or MySQL, but what particular type of application does a deployment typically cover? Stateless, right? So stateful is typically what we're looking for, right? Stateful sets in particular are used for stateful applications. Deployments are used for stateless. That's a general rule. So deployments are the recommended way. And so when you actually like look at a deployment file, what's going to happen is that when a deployment is created, Kubernetes is going to evaluate the resources that you've asked for. If you haven't asked for any resources, by the way, it's going to assume minimums and just spin them up, right? But it's going to figure out what nodes it can run things on from a binary standpoint. Like, does this node have capacity? Does it have free disk space? Does it have free memory pressure? Is it in a ready state? And then it's going to create the pods to run on the particular nodes that qualify. And it does, by the way, assign a value, which we'll talk about scheduling here in a little bit. It's going to create the pods as needed to hold the particular app in question. So those are the unit of deployment, right? Is the pod itself. Then it's going to determine if the app needs to run multiple, and then it's going to schedule the instances on the kubelets. And the kubelets, by the way, are going to pull down the app, set up the pods, do everything, and then they're going to report back to the master and say, hey, by the way, I started the pod you asked for. Here's its state. Here's some information about it. And if instances fail, right, especially if there's a change in state, right, among the particular pods in question, it's going to continue talking to the kubelet and the master and going to say, hey, I just lost one. How many do I need? Oh, 4. Okay, let me start one. There's only 3 running. Let me start another one. Kubernetes will create all the components required for the deployment that are defined in the deployment, plus any additional metadata. When deployments are deleted, generally, Kubernetes is going to delete all the associated pods and the containers as well. So we go back to our Minikube dashboard we were looking at before, and we come in here and look at the deployment, for example, let's say for Nginx, and we look at the actual file. Notice, by the way, see this kind derivation? If you didn't know what that should be, you could literally come back here and look at your, actually, let's start another one. You could run a kubectl API resources command, assuming that you can spell resources correctly. And you could actually parse for a deployment type. So for example, if I wanted to basically grep for deployment, because I didn't know the details there, I could find out that the deployment name was actually deployment, and that's what I need to stick inside of my deployment file. So this is a deployment. Look at that. See how it says kind there? Capital D deployment, right? Notice that under API resources, it also lists the apps version 1. That also, by the way, lists apps version 1. So if you were writing this by hand, which by the way, most of us don't do, we usually just pull either other copies from our libraries or we just pull an example, right? You could actually like look this up by using that API resources command. That would actually give you the answer to your question. Notice here that there's some metadata, including the name, the namespace, right? Everything basically it needs. What app, right? What labels is it applying to the system in question? Some of this, by the way, was all added by Kubernetes because it's actually pulling it from inside, but some of this isn't necessarily defined, right? And then here we have the spec, which is probably the field that was actually defined in the original file, which says I want 3 copies of this system. The label I'm looking for is I want to match the app label of Nginx. And then down here is the image source, which is going to pull, right? In this case, from whatever the assigned repository is. In this case, it's hub.docker.com. Any termination messages, set for restart policy, grace periods for shutdown, for termination, that kind of thing. Strategy for rolling update, meaning it's only basically going to make 25% of the available replica sets unavailable at a time, right? And it's only going to allow 1 extra pod per instance, if there's 4, for example, right? As an example. So, and then there's other like status information in here. That was all added by Kubernetes. That wasn't stuff that was in my original deployment file. That was all added by them, right? But this area between line 97, this spec, those are pieces that were all in my original Nginx file. So Kubernetes is going to create everything that's defined in that deployment file. Go ahead.
I'm curious about so deployments. So they contain pods, but that definition of the deployment didn't have pods. It referred to containers. So
Right.
is there? Can you have a deployment that refers to existing pods and have those pod definitions separate, or does a deployment just automatically refer to the containers and then pods are created for those containers?
Pods are created for the containers, right?
Okay.
Now,
So
don't get me wrong. You can create a pod object if you want to, and it can be done. Would you refer to an existing one? I don't know that I've actually done that, because just so you know, deployments are immutable in terms of versioning. So you could link to other pods into your like deployment definition. But for the most part, everything's greenfield in there, right? You would refer to an existing container that would then get pulled into the deployment set, right?
Okay.
Yeah.
Got it. Thanks.
Remember, deployments, by the way, are typically single application also. In other words, there's only going to be one deployment for the Nginx type. There's going to be another deployment for the web type. There's going to be another deployment for the MySQL type. You can orchestrate those together very easily, and you can actually specify multiples if you want to. But linkages between them are usually done through separate deployment files per se. When you create stateful sets, by the way, you can create dependencies and linkages together. But for the most part, you're going to externalize that and have them speak to each other through some kind of orchestration methodology. Yeah. All right. Here's some basic deployment commands. So someone asking earlier about create versus apply. For example, I don't think you can even run apply deployment. I think you have to run create deployment. I don't even think that's an option inside kubectl. Let's see. Yeah, I don't think there's even an option for doing a create. I think this is just now options. Apply prune, apply -f. I don't think there's a create option even in apply. So create is the only space where you would actually do this. In this case, by the way, notice that you're giving it almost no information, right? You're basically just specifying an image. You haven't set any replica sets. You haven't specified anything else. So if we actually do this, like if I'm actually doing kubectl create deployment, let's say Nginx2, right? Where image equals Nginx latest, right? Same thing. Only thing I changed was I didn't call it deployment, but let's, for consistency's sake, let's call it deployment. It instantly created, by the way, right? Boom. Just ran an image. Didn't ask me any questions, didn't ask about replica sets. It made some assumptions though about what I wanted. By the way, since this is totally stateless, by the way, and I could add volume. I could have added a volume into the deployment file if I created an Nginx deployment file. But if we go look at this, look at the Kubernetes dashboard and go look at deployments. Now there's a deployment type here, right? I go look inside of it. What's happened is this made a bunch of assumptions about what I want in terms of like the defaults. By the way, you can actually change the defaults for the entire cluster if you want to. It assumes I only wanted one, which is probably totally fine since I didn't tell it anything else, right? And it created a replica set, which it was an object that I didn't define, but it defined, right? And then it basically is just showing up events, which basically said, hey, I created the account. If we go look at what's inside this YAML file, I didn't create this YAML file at all. Only thing I gave it was basically a name. I didn't say anything about the namespace, right? Tom, it breaks my heart a little bit that I'm glad you're asking, but I'm like, man, I must have done a bad job explaining that earlier when we had the thing, because I was like, it is still pretty vague, actually, right? So I'm going to come back to that. Let me finish this first. Notice, by the way, under specs that like I didn't add any of this stuff. This is just all defaults. The only thing that I gave it was this image thing right here. That's it. Everything else, it just kind of did itself, right? Figured all the rest of this out. So it can be that simple, but this is not typically what we do in production because we want a little bit more control over like rolling updates, how things are set up, you know, adding volumes as an example, right? But it can be that simple. It's just simply the create command in order to get a deployment. We could do the same thing, by the way, with you know, Mongo, right? Although that is that's a stateful app, so it might be interesting, right? But like if you could replace that with anything you wanted to, as long as it was a valid image, it would create it, right? You want to put Apache web server in there? Awesome. If you've got the image available in your system, that's a very simplistic way to just create a deployment. This is not really the production way to create a production level deployment. You might say, well, what's missing? Well, you might want to control your update strategy. You might have persistent data. You might define different aliveness and readiness probes. There could be a bunch of other things that you might want to configure. Again, this is probably the reason to a certain degree, whereas users don't typically get direct access to a Kubernetes cluster, right? Because sometimes they don't know what questions to ask or what things have to be attended to from a security and operational perspective, right? For example, what if there had been an expose in there, but we didn't allow exposing through whatever cluster IPs, only through load balancers. But if the load balancer was going to be exposed to the internet, we weren't going to allow that at all. Like that's not kosher for us. So just remember that using the kubectl apply command or create with the -f, this is the most common way by which we create production grade resources. But if you're just messing around, this is a great way to create deployments. Just to validate that, if I go back and look at the deployment, yeah, there's the MongoDB. It's up, right? By the way, notice that I knew offhand that it was called Mongo and not MongoDB. Like you do need to know the exact name of the image. If you put MongoDB in there, it wouldn't work, right? It's just called Mongo out on hub.docker.com. By the way, once it is in here, you can scale it from the command line. You can also scale it from the dashboard. You can actually change any and all of these from the YAML file, or I think you can actually just, I don't know that I've ever done it from here. I think there's a way to just like turn it up where you can just like turn up the number. But usually I just do it through YAML. Okay, Tom, back to your question. Let's talk about this. Let's make sure I get this clear. All right, so then what's the difference? Because that's the big question. If I can actually add storage to deployments, and I can add storage to stateful sets, what's the big deal? I can add config maps, I can add secrets to both. What's the big deal, right? Again, the difference is how the naming of these systems is handled. So let's say the green pods are stateful sets, and these were just, the red ones were created with deployments. The difference is how it handles the naming of the pod and service discovery. These pods, when they are destroyed, will not get recreated with a random name, even if they're on another host. They'll keep the name. So if this was Nginx MySQL-0, this one right here, this first one, and this guy was MySQL-1, and this guy was MySQL-2, if for some reason that host fails and it's recreated, which doesn't matter because my storage is external, right? Then what will happen is the name will stay the same, which also means the DNS name will stay the same. Now the IP address could change, but the DNS name will stay the same. And the service point entry will stay the same as well, which that's what service points are for. So that's not necessarily a big differentiator, but the name of it and the DNS name of it will stay consistently the same. So it can be found easily. It assumes, by the way, that you want, when you do stateful sets, that you want to find these a lot easier, but that's the main things that shift, is that the naming is the main distinction. And the service discovery is the main distinction. Other than that, there's no limitation on what you can attach to these, right? It's just how Kubernetes handles them. Now, just to answer that, Tom, you're hitting on something that's actually super important. Is that good enough for you to run a data store inside of Kubernetes? And the answer from the community is that it's not. It's not even remotely good enough. So I'm just going to preview this just for an example. So what they came up with instead is that if you want to actually add DevOps type logic to Kubernetes so it knows how to manage the data stores, they've done this thing called operators, which allows you to extend your Kubernetes cluster so it knows how to handle these things better. It knows, for example, that the first MySQL 0, right, is actually the most important one because that's the read write for MySQL. And then it knows that the second ones are read only, right? So what they've done is they've added these operators for MySQL as an example, right? Which allows you to basically manage these in a more intelligent way. Because otherwise, without this kind of intelligence inserted into Kubernetes, Kubernetes is just going to bounce these things, even though their naming convention is staying the same. It's just going to bounce these things and do whatever it thinks it needs to in order to float them around, right? But that can cause like problems, especially if it's interrupting like existing connections and services. So the community the Kubernetes community came up with a way to insert more intelligent logic about how Kubernetes should either gracefully shut down or start up these services, and how to maintain some equanimity around connectivity with storage, like how to manage that whole thing. Because like back in 2017, I ran Elasticsearch, which is a NoSQL data store in production for a small, it was a medium-sized company that did ad tech. And everyone was like, oh yeah, we'll use stateful sets. They just came out, they'll be awesome, not a problem. But the problem is that when Kubernetes bounced a system, yeah, Mike, they are open source. Yeah, Operator Hub.io, I think is operated by Red Hat. And so there are some proprietary ones in here. They don't cost you anything. They're just proprietary to the technology that's being used, but you can download these and use them as you see fit. What happened with the Elasticsearch cluster is that Elasticsearch would bounce a node, but here's the problem. Even though it was connecting to the same data store and it was still the same version of Elasticsearch inside the pod, Elasticsearch, the minute it restarted, rescanned all of the data for veracity. That's normal for a data store, would it not? Data store like comes back up and says, I just took an outage. Let me just scan everything and make sure it's consistent, right? Well, with it, I think it was like a 5-6 terabyte data store. That took a minute. Well, then Kubernetes would bounce the other systems. And you know what happened at that point in time? In a 10 node Elasticsearch cluster, if 3 of the nodes got bounced, meaning they were bounced up and down, because Kubernetes was like, hey, I need to move you to a different host. The only thing the cluster was doing at that point was data verification. It actually stopped feeding out to consumer requests. And so what ended up happening is that, and we didn't have, the operators weren't around back then, is that when you add the operators in there, what it does is it now does simple things like, hey, Elasticsearch just start. You don't need to do a consistency check. Why? Because you haven't lost any data. How do I know that? Because I'm monitoring storage, right? Or, hey, only do a consistency check on these blocks, right? So it's little things like that. Like that's just a flag when you start Elasticsearch, right? But if you didn't do that and Kubernetes bounces it, it's going to go back and scan the entire disk to make sure that data is consistent, right? Which again is great when back in the day when disks were physical and you were using blocks and blah, 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 blah. But just to say this, the storage system on the back end of the Elasticsearch cache had 3 copies of just that disk for just that pod. There was no chance, there was minimal chance of data inconsistency. But that's what the operator does, is the operator adds like DevOps kind of like Kubernetes logic to how Kubernetes handles these things, so it knows how to manage these data stores appropriately. Most of these operators are for data stores and machine learning applications. So like, for example, most of the providers that I've seen actually have one out here. So MongoDB, for example, has an operator for MongoDB itself. You know, Cassandra has one. Right, Cassandra operator, like, so most of the data stores have something. I don't think Neo4j has one. Yeah, those guys need to catch up. Anyway, Neo4j is a graph database, very specialized use case. But if you need to add basically DevOps intelligence, you want to look at an operator. By the way, people write their own operators all the time. Red Hat has a great class on how to write your own operator online. I don't know if it's still free, but it was. So you can write your own operator. So if you want to insert your own logic for how to manage your applications, you can do that as well, right? So anyway, just give you a preview about how to make that more intelligent. But I hope that answers the difference, is that there's a minimal difference between stateful sets and deployments, just that naming and service discovery piece. If you really want to make it different, then add an operator in for your stateful set extension and make it so that it understands how to manage the data store in question. Good. All right. Let's see, there's a number of like pieces here as far as like, you know, obviously just, you can use create or apply to basically specify a file, right? Create obviously is the only one that will allow you to do this crazy thing, right? Obviously, you know, I didn't show that because we were looking at the, but if we want to get all the deployments, this shows the the MongoDB and the additional Nginx one that I ran, right? If you want to scale it, you can scale that as well. We'll show some of that. If I want to check the rollout status of a deployment, for example, that's just that command. I can also obviously look at the rollout status inside the dashboard. Get deployment details if I want to like make it wide in YAML, and if I wanted to delete a deployment, which by the way, you need to delete your deployment or your stateful set to get all of the objects deleted out of the system. Like, I'm a little bit curious earlier. You may remember yesterday when I was looking at my cluster, when we were looking at Minikube, we were in here. Oh, I think it was this morning, actually. We were looking at persistent volumes and I was like, why is this volume still here? Right. And by the way, the reason it's still here is because the reclaim policy is set to retain, right? It's not set to delete. So when I actually got rid of this, when I got rid of the deployment, it actually retained the volume because that was the policy status. Most of the time, it's going to release these volumes back unless you actually set it that you want to retain the policy in question. But that's pretty cool, right? Because that means you can make it so that your deployment, even if someone comes in and accidentally deletes it, you can still retain your volume data, right? Because there are some things you don't ever want to lose. Like if this was a database, I wouldn't want to lose this. If I had heavily invested in this Jenkins system, I definitely wouldn't want to lose it, assuming I didn't have any externalized backups, which is bad practice, by the way. You should have externalized backups. All right, so delete deployment, check deployment details. We have labs on this, by the way. All right, so to update a deployment, you could just reapply the YAML file. That's basically what it's doing when I come into the Kubernetes dashboard and I'm in here messing with a deployment. If I come in here and say, look, I got 3 Nginx systems and I want to basically come in here and change the replicas. Not status. Nice try. I want to change this to 5. When I hit update, it's just applying. It's just doing a kubectl apply of that YAML to that object. And so at that point, what it's doing is it's just increasing it to 5. By the way, that happened really fast, didn't it? If I go look at events, by the way, hey, it looks like I scaled up to 5. Cool. But that's all that is that it's just when you apply YAML and there's a difference between what the object has and what you've defined in the YAML, it applies the differences. So if all I've changed is the scale number, then it just changes the scale number. That's it. That's all it does. We've seen describe earlier because that's one of the key ways to troubleshoot, right? You can also get events out of the system and you can get logs out of the system, right? Recent rollouts, by the way, can undo it. So if I want to roll something back, I can actually just roll an undo command. This is actually in our labs, just being mindful of time. And then I can actually set an image if I want to where I can override the image definition that's there currently, and I can set it to a specific image. Like, you know, let's say I was running 1.7 or something and I want to update to 1.91, right? You can do that. And you can also scale it. So you saw me actually scale my earlier deployment by basically just going into the interface and doing it. If I do it here, not by running that. If I do it here, it's cracking me up. Just so you see the command in action, right? I can basically just scale the deployment. Assuming I can spell deployment correctly. By the way, that's a really long way to type that command. But I'm just going to go with it as an example. But let's say I want to scale this up to 3, right? By the way, you saw up here that the deployment was set to 1, right? If I come back up here and get deployments, you'll see that it's actually scaled to 3 now. So I went from 1 up here to 3. When I go back down to 1, boom, it's back down to 1. Just that simple. Again, this works well with stateless apps. Gotta be just a little careful with stateful apps, right? Because for example, what if you ask for more storage than you actually have capacity for? Hopefully that's not a problem, right? Or what if again, it's a RDBMS, you gotta be careful, make sure that you've got readers capacity and like the application knows how to talk to the readers. If it's a NoSQL database, typically that's not necessarily an issue. You don't need to worry about that. That's just that simple to delete it. Object's gone, all the replicas are gone, the replica set's gone, the pods are gone, everything's out, right? Any questions about any of that before I move forward? In your lab, which I think just based on timing, we're not going to get to till after lunch. In your lab, you're going to actually run through all these commands. You're going to scale something up. You're going to roll out a deployment. You're going to pause the deployment, unpause the deployment. You're going to roll it back to a different version. You're going to change the image set. You're going to do a bunch of these commands. So pods, we talk about networking, right? One of the two things hard, right? So pods running in K8s run by default on a private isolated network. By default, pods are only visible from other pods within the cluster, right? So this allows applications in one pod to tackle applications in other pods, right? So it's pretty wide open. But pods are not visible outside the cluster, right? So things outside the cluster cannot like see into the cluster, right? That's what expose is for, right? Means we can't call applications in pods from the outside, but that's what services is for, right? Again, we've talked about this, right? If you want to expose a deployment, right? In this case, right, we're actually calling a server Nginx deployment. And then this type is a load balancer. Now, if you have set up a load balancer in your Kubernetes setup, it's going to use that. But you also could use a cluster IP. You could also bind to a particular node's network stack. Not recommended, by the way, right? But this is the port that is exposing, is port 80. Now notice by adding it, what's happened is that it's given a cluster IP address and there's an external IP address pending. Once that's been assigned, you're going to get an extra, don't do that. Sorry, clicked on something active. Is that once you get the cluster IP address, right, you can actually access that externally on 31.315.21. But if it is assigned an external address, you can access it through that. You can also assign it through the cluster IP address. When you're using Minikube, by the way, if you do Minikube service and then type in the service name, it'll automatically like connect you URL wise to the system in question. So Minikube does actually make that really easy, but that's not the way regular Kubernetes functions. So just that's a Minikube convention. Are deployments only for a single image, or is that just the default for CLI things? they can actually, you can actually put multiple like pods if you want spec in there if you need to. So it's not it for for this particular piece, it's just like the default, but you can actually orchestrate multiples in there if you wanted to. So namespaces we talked about, so you can actually deploy things into particular namespaces. Default is usually where things go. If you apply something, you can specify the namespace. If you create something, you can specify the namespace. By the way, I think it's just dash in. That's what I typically use versus dash dash namespace, which is the long format, right? But you can actually specify the namespace at creation time. You can also specify the namespace in the YAML file. Like you can say, I want you to go here and do this, right? You can get all the pods for all the namespaces. There, you can either use dash capital A for all namespaces, or let's show that in action. Actually, that probably makes more sense. So are these all the pods that are running on the Kubernetes cluster? Like if we go over here, back to our dashboard, are these all the pods that are running on the cluster right now in Minikube for this particular setup? Have we seen any other pods on the system? Well, if I switch my namespace to all namespaces, anything else show up? Actually, other things show up. Remember the core DNS and the Kube API server and the controller manager and the scheduler. And by the way, that's the storage provisioner service, right? Dashboard I added, right? All this stuff is actually running on as pods on the system. So if we go back to this command, right now it's showing get pods. If I run a dash A, ooh, what just happened? So if you come into a space and you don't see your particular pod, it's probably because contextually you're running in the default namespace. If you want to see something in a particular namespace, by the way, I don't have it. Well, do I think we run in Jenkins? Let's go take a look at namespaces. Yeah, I don't have anything running in Jenkins. Let's see. I should though. What about Ubuntu? Anything running in Ubuntu? Nope, nothing there, right? What if I wanted to look at Kube system? There's some stuff running in there, isn't there? Right? So remember, the namespaces act as like layered. They can be cordons. I'm an administrator, so they're not blocking me from seeing anything, right? But they act as layers. If I want to create new namespaces, oh man, I'm just like mistyping badly today, right? Right, and then I just created a new engine. Oh, I actually created an engine 9X. That's excellent. Good. I'm so glad I could create that one. Right. But these are just basically security cordons, right? Let me just delete that one because it's gonna drive me crazy. Oh wait, how about delete? Wow, my brain just completely stopped working and I just started stacking commands together. So I apologize you had to witness that. All right, so that one's been deleted. So the namespace that you're in actually matters. For most of us, we're not going to deploy into default. What's going to end up happening typically, especially if you have a multi-tenant cluster, is that one, even if you don't have a multi-tenant cluster, you're typically going to create specified namespaces for different functions. You're going to have a namespace for monitoring. You're going to have a namespace for logging. You're going to have a namespace for Jenkins. You're going to have a namespace for web servers. And if you're running a multi-tenant cluster that is actually for people who are inserting their applications, you're probably going to create namespaces on a per project or per group basis. Meaning that if Jeff is part of like security group B and Tom is part of security group C, you might actually have namespaces so that Jeff and his team can mess around in that namespace all day long, and your permission sets can be more granular, whereas Tom can mess with his stuff all day long and nary show the two paths cross unless they absolutely need to, right? So, you know, namespaces can be a great security cordon, especially if you have your policy set up to support that. Okay. Other useful commands. Oh yeah, other useful commands. So get pods, we've shown in general. You can get anything, right? Get whatever you need, right? Describe, we've shown you can describe, get more detail than you need. We've shown that, right? Exec is interesting because this allows you to take, for example, a running pod, right? And execute some command inside of it. You saw me actually run into problems with this earlier because of my git bash set up on Windows. I need to switch over to Ubuntu as soon as I can, or whatever, right? So, but the interesting thing here is that this presumes, by the way, that the shell is inside the container. If you've run a bare bones container, like you did from scratch, and you don't have Ubuntu or some kind of other binaries in the system, you can't run that command because it doesn't exist inside the container, right? And so here we are executing against Nginx. You can actually execute bin bash inside of the shell. It runs the shell inside of it, right? Other things that are useful for troubleshooting, because that's what you would do. Like you have a running pod, you've got some kind of problem with the container inside of it, you just execute it against the pod and hop inside, right? But other things that are useful are like get logs, for example, if you want to like get it for the system in question. So if we do a kubectl get pods, there's a bunch of stuff here. Let's say if I want to do a kubectl logs and I want to see what's going on. Oh, this thing had 4 restarts. What was it doing that I had 4 restarts? Oh, that doesn't tell me anything. It does tell me that it's ready for startup, right? Looks like it launched an environment substitution on templates, did some kind of tune worker process. Interesting. Listen on IPv6 by default. Anyway, if this was active and had some information that it was outputting to the console, it would actually show like information about what's going on. I'll tell you what, one that would be kind of interesting is what's going on with this one. I wonder if this one's done anything. That's funny. So basically saying a container name must be specified for the pod. Oh, interesting. That must have been the first error. I think I modified that so it would function. Anyway, so logs will show you anything. So, okay, here's the cool thing about Kubernetes. Oh, wait, hold on. There was a question. If you have more than one container in a pod, which container will it use? Oh, you mean in terms of like attaching it? You can actually specify like inside a particular pod, you can actually specify the container. You can actually sub-specify the container in question to get to it. Yeah. Yeah. So you can do a colon and specify. So if you need to hook into a particular container, by default, it's going to specify the one that you've set as the primary, right? It's the one that's running like the default app, right, inside the set. This, by the way, is why typically, because the other ones will be set up as sidecars for the most part, and the one that's not set up as a sidecar is considered to be your primary container inside the set. So, yeah. So you can specify any of the containers inside of a pod just by adding the extra variable to do so. So kubectl logs. Oh, so this is the cool thing about logging inside Kubernetes. Anything that is emitted by the application to either standard out or standard error, like kicks out to the terminal, Kubernetes is going to capture that and it's going to use that and write it to a log file on the local file system. So that doesn't mean it's going to persist if the node gets deleted, but that means that remember all that stuff where you're trying to like capture what's on the console, you want to see what the application's emitting. Well, anything you emit out to either the standard out or standard error is actually going to get written to a log file. Kubernetes is going to capture that. You can actually ingest those log files if you need to, but that's what this is reading. Anything that's emitted actually off of the terminal is actually what's being written to, and this is what's being captured by kubectl logs. So, which is kind of nice. Normally, by the way, you have to go through some kind of advanced orchestration process to either emit log files or whatever in your system. Best standard practice for containers inside of Kubernetes, just have it emit everything to standard out and standard error, and it will get captured. including all the log emissions. Now, if you do not have a strategy on your Kubernetes cluster to capture and copy those log files out somewhere else other than the node, you're going to be in trouble. So you do need to come up with a logging strategy for your Kubernetes cluster, because Kubernetes doesn't handle that. Kubernetes will capture the logs, but it will not export the logs out to a centralized system. So just something to keep in the back of your head, right? All right. By the way, this allows you to copy local files by using kubectl copy into a container in a particular file system, this particular case. So that can be useful, other like useful commands. All right. So what we did is we covered a random smattering of like how you can connect into Kubernetes, right? Using the dashboard, using a curl. Thank you, by the way, for the correction on curl command. I lost my mind there for a second. I'm not sure why I didn't even think that was talking to a specific service. Thank you for that. And then obviously using kubectl. We ran through a couple of different spaces around why services are important, the difference between deployments and stateful sets, how to slice up your cluster with namespaces and how that shows up in your kubectl command. We did not talk about scheduling or node management, but don't worry, we will. That's actually the very next thing. So our next step after this is actually to do a lab to reinforce the commands that you just saw in the lecture, but we're not going to do that right now because it's 11:51 and I'm 1 minute past my promise. Does anyone have any questions before we break for lunch? Cool. All right. So we're done. So come back at 12:55, just like we did yesterday. So it's an hour and 5 minutes from now. I'll put a timer up. We're going to roll right into a lab and I will see you in 65 minutes. That system. For example, if I'm in AWS, what else might be on the master? I could have a cloud controller for AWS. If I'm on Azure, I could have a cloud controller for AWS. What if I'm running persistent storage? What if I'm hooked into storage somewhere, right? That's the other thing that can be on there is there could be a storage controller, right? So again, just in terms of like you understanding possible attack services and things to be aware of, these are services that will most likely be running in your environment because most of us are using storage. And if you're on a cloud provider, or even if you're hooked in with like say VMware or something like that, you could also have a controller running, right? Because they consider themselves a cloud. This is probably worth stating. You can only have one active master at any given time. They do an election, right? They figure out here's your primary. If that one's lost, another one becomes primary. So they do actually do an election to figure out who's going to be the active master at any given time. Let's see. The kube control manager, right, which is part of the master node, right? The controller manager is responsible for controlling the following subcontrollers: node controllers, replication controllers, endpoint, service account, token, right? Token we've seen because someone earlier was asking a great question about, hi, how can I get authenticated access using curl without using kubeproxy, right? You can actually grab a token, right? But that has to be authenticated. And then a service account. So it's interesting, like users are usually represented by like certificates and tokens, right? Service account is one of the few user objects inside of Kubernetes, right? And that's basically where you're running something as a service and you basically are giving it a particular account to run as. Endpoints are just the API endpoints. Replication is for replica sets in order to be able to replicate pieces. And yeah, has other aspects as well. And then the node controllers, like how do I interact with the kubelets? How do I make sure they're healthy, ready status, stuff like that. So they're compiled into a single application that kind of does all this, but there's subcomponents inside the controller, right? So this is what actually like manages and runs most of the cluster's components. And then the nodes we talked about before has kubelet on it and kubeproxy typically, right? And so I don't know if there's anything else to say about this. Obviously, you can have one or more nodes. We talked about 1,000 nodes, can be configured manually. You can add, by the way, what's the command? I think some of you have done this already. What's the other kube command that you can use if you need to manually manipulate a Kubernetes cluster if you want to add nodes to a cluster, right? What's the command for that? I think some of you have touched this already. It's really the only other kube command that we ever really mess with. Well, that's an action for kubectl, right? What's the other command that also starts with QUB, kubeadm? Yeah, there we go, Tom. Kubeadmin, right? So that's the other command that we use. By the way, in Kata Coda, the link I posted earlier for Kubernetes, which I'll repost again, that actually has a little kubeadmin kind of scenario in there if you want to actually put your hands on that. Pods and containers, I feel like we've kind of like run this to death a little bit. And then interacting with Kubernetes, we've hit the API server. Actually, because the question earlier, we hit the API server with a token. We went through kubeproxy. We've interacted with the dashboard and we've used the CLI. So good. So that's just I guess a quick little checkpoint review. I guess they were assuming that we had not done a review earlier. Let me just look at this really quick. So I want to make sure this is worth our time. Oh yeah, actually this would be worth our time. Oh, and it sets current context. Oh yeah, this is good actually. So this is a good lab for us to pivot off to because you'll be able to set context. Context is, by the way, when I was looking at the context file earlier, like it basically allows you to switch and manage different clusters, but you got to switch context and manage them. You can't manage 5 clusters at the same time. Don't get me wrong, there are tools for that, but for the most part, you have to switch context, because you'll see that inside the lab. So we're going to pivot over to lab 6, where we're basically going to create a cluster, get clusters, delete a cluster, right? Interesting. And then we're going to create another cluster. Yeah. And then we're going to run kubectl and we're going to basically look at our context. So we're going to get the current context. So we're going to get the current information that we're using. And then we're going to get our nodes and look at our like data plane, like our master plane, control plane versus our application node plane. And that's good. Describe the nodes, describe the control plane, write that out to a file in case you need it. And then we're going to look at the worker nodes and we're going to do the same thing. So you're basically going to like manipulate your own cluster. This is going to be a really quick and short lab. Get about maybe like 15 or 20 minutes for this. So let's go ahead and pop into lab 6, just run through it. I'll check in at 15 minutes and then we'll move on to other material. Any questions? Okay. Let's do it. we have covered things just like a few pieces on cloud native security, which is just going to dip its toe in the water. I know you guys are like, feed us more on security, right? But this, we're just going to skim a little bit. Access management and then namespaces. So, oh yes, no, I should be recording for long. Thank you. Thank you for checking. All right. So typically when we talk about cloud native security, it basically goes from the core out, right? We're talking about, okay, what's going on with the code? What's going on with the container and therefore the pod? What's going on with the cluster, right? Its particular piece of software, and then what's going on with the infrastructure around it. You know, there's just teeny little diagram over on the left-hand side that talks about this concept. But basically, you know, to consider it, it's basically every time you have an instantiation of code or an application of some type, that's how you need to think about it, right? So obviously we've got the core application. Let's say it's our little fabulous Java application, but then we've got all our like application itself, but then we've got the environment that it's running in, right? That also needs to be considered. Then we've got the container runtime software itself that has to be considered and thought about, right? Then we've got all of the context around the Kubernetes software that we now need to think about, right? And it's all the components of the cluster. It's not just the component related to, hi, how can I escape out of here? And, you know, then I got to worry about what the kubelet and proxy, and is there any, how is that all authenticated and how does that get back to the masters? Right, which by the way, the earlier reference of being able to escape from a container that's running on the actual masters, well, that solves that network hop right then and there, because then etcd is right there, the API server's there. If there's an emissions controller, it's right there. And then perhaps I can get better access to some of that, right? So you got to consider the software at every single layer. Then I've got the operating system that Kubernetes is running in. That's also another consideration. I got to think about that, right? And then of course, what's beyond that, right? Are these virtual machines? Got to worry about the hypervisor. Then I got to worry about the rest of the components of the environment. What about the storage subsystem? What about the networking subsystem? Is it in cloud? So therefore, is this whole other set of subsystems that I might need to pay attention to and worry about? So while it talks about it in general around 4 layers, around like code, the container, the cluster, and then the environment, there are subtleties to all of those layers that also need to be considered, that are actually literally local to where the software is running. These aren't even necessarily remote systems, right? We can get down to the hypervisor, potentially even down to the bare metal, right? So the context here is important. So to ensure code security, oh, this topic is, so obviously this is a topic that's been discussed for 20 years. How do we create and like procure, make, sustain, patch, all this stuff around secure code, right? I like it says protect code on the move by using TLS and SSL security. Yeah, sure, if you're copying things around, right? Most of us are doing that through SSH, right? But make sure that obviously if you are pushing it up and pulling it down, that it's on a secure channel. But excuse me, static code analysis, running code analysis, right? Penetration testing, vulnerability assessments, all that, like this all stacks in, especially once code starts running, right? But just for code security alone, there's a whole swath of tools that will do this and a whole swath of methodologies. Now, container security and by proxy, cluster security are relatively new things because, right, containers came out in 2013. Kubernetes came out in 2014, 2015. Oh, well, am I not sharing my screen? Yeah, probably sharing my screen would be good. Here's that tiny little diagram, by the way. I don't think I can blow that up enough. Code, container, cluster, right? These are the 4 general layers: code, container, cluster, infrastructure, right? In this case, cloud. Remember, there are subtleties in those pieces that I just talked about. Thank you, by the way, for pointing that out, Tom. Let's come back a little bit more. There we go. All right, so we're talking about code security, container security. All right, so so this is where they get you is transitions and exposure, right? So you've got code, it's in a code base, And then what happens is we're going to build the code. We might even merge it. During that merge, there actually needs to be some kind of analysis, right? But let's ignore all that code conversation because people have been talking about it for 20 years. Let's talk about the container conversation, right? So then you're going to build a container. Well, first of all, what's in it? So the container itself, the image itself has to be scanned statically, at least for known vulnerabilities. By the way, if that's predicated on another image, right? It's what things are embedded in there. So the whole image needs to be scanned, right? For any kind of vulnerability. Obviously, if we can create trust and veracity by signing or creating some kind of signature or some kind of stamp for the container in question, making sure that nothing can be released unless it meets the standards of the signing or the signatory. Making sure that containers, for example, not only have the necessary privileges inside, but also that they're running as the necessary privileges. There's a rootless lab inside of the Katacoda setup. By the way, OpenShift was one of the first to pioneer, like you can't run this as root, which caused all kinds of problems, by the way, because everybody was used to their Docker containers running as root, and that caused all kinds of issues, right? And so making sure that the container doesn't have anything unnecessary running, isn't doing anything untowards. But then just to say this, once the container is running, it ideally is also scanned there as well. Yes, they are immutable, but that doesn't mean that something can't be happening and triggered inside the container that one, you didn't see coming and didn't know about, or two, that someone didn't log into the container and do something about. Now, obviously, there's also a certain level of access restriction for that as well. And that probably speaks a little bit more to the clustering side of things. But still, it's an issue. Like, for example, Aqua, Twistlock, and StackRox. There's also, I think, Tigera. Aqua, Twistlock, StackRox, which actually I think I just posted a report from them. And I believe it was Tigera. Maybe it wasn't. It might have just been bought, by the way. Let me just look that up. Yeah, security. I believe it was Tigera. Signal Sciences, security and observability. Yeah, I think it was Tigera, but I could be wrong. But Aqua, Twistlock, and StackRox for certain are kind of considered like the de facto kind of scanning tools that are used, not just with containers, but like StackRox is I think is the only one. I think Aqua and Twistlock added this later on, but like StackRox is the only one that was built to scan containers once they were running to maintain a certain level of policy on them, right? And Aqua and Twistlock added their features in later, but StackRox was written from the ground up. StackRox, by the way, just got bought by Red Hat. And is actually run by a former Google engineer who saw a particular problem that needed to be solved, which is basically how do I track, trace, prevent, maintain, and policy, right? Running containers. So you need a tool. Obviously, you need a strategy. Strategy comes before tools, right? Come up with a strategy, but you need one for static containers when they're built, and then containers from when they're running. And that, for the most part, will handle like what's going on with your container like pieces. It's like, here they are as an artifact, here they are running. You need to be able to track both. Running, by the way, does require integration with the cluster, right? Now, once you're inside the cluster, what tools do you use to secure things? For example, like making sure the etcd cluster, one, isn't DOS, isn't the denial of service and can be protected, isn't accessed inadvertently. Do you keep it on the same thing as the masters, or do you segment the etcd cluster out, right? How do you prevent unauthorized and unauthenticated access from a variety of different vectors and attacks, of which some of which are known for Kubernetes and some of which just need to be mitigated in general because they're good practice, because we don't yet have a vulnerability, but they could be. Like, for example, escaping from a container or a pod to be able to get to other pods or to the host on the system. Those are the kind of problems that we need to be thinking about, not a matter of like really if so much, but when these things are going to happen, right? How do we maintain secure access to the kubelet? How do we maintain secure communications, by the way, between the kubelet on the nodes versus the master, right? And then luckily, unless etcd is externalized, we still need to secure the communications between all of the different services that sit on the master, just in the off chance someone is able to get in and do some kind of interception, right? And then, of course, that's just Kubernetes internals, right? when we go back to this first section about applications, like code security, with this running container, these two sections here, the minute we expose something out, whether it's just cluster IP, or if we're exposed to service and things are coming into the service, then we're opening up a whole slew of layer 7 attacks, distributed denial of service attacks, especially if they just want to like basically overwhelm the cluster, right? Even worse, by the way, I've had people where they've actually made their clusters auto scale out on nodes, and they bumped the service limits way beyond the norm, and they got DDoS, and the thing just started scaling, right? And that broke the bank. That didn't break the service. That broke the bank. They actually had to literally cap it and say, oh my God, we just started like whatever, 600 nodes. And they were like, we got to pull this thing back. And I was like, yeah. And of course that, luckily they had a support team with the AWS that was able to mitigate. The Shield Advanced is the name of that product. But anyway, regardless, for a moment there, their service was knocked offline, and they were about to spend buku money to achieve service continuity. So they're like kind of things that you got to think of, right? Let's see, what is the scenario for attacking a kubelet? Internal only, or do they accidentally get exposed to the service API network? No, I mean, the kubelets and the masters have to talk to each other, and they will co-initiate. So it's not just one way, right? So that authentication is usually, encrypted. I'm sure there's an attack vector there, but I don't know it off the top of my head, but I'm sure there is, because it's exposed across the network. I'm sure there's been CVEs and other attacks that could be used, right? It is mutual TLS by default. So, and if you run through Kubernetes the hard way, they'll make you set all that stuff up manually. So you can actually see every single piece of interconnectivity, including the setting up those certificates, how all that's wired together. So yeah. If you really want to understand the internals about the attack surface and all the stuff that happens for just plain vanilla Kubernetes, it's right there. Now, word of caution, that's going to give you the exposure if you take Kubernetes out of the box. For most of, for example, service providers, or if you grab OpenShift, Rancher doesn't really change this so much, although it can. A lot of that changes because they'll add their own security profiles on top of the entire Kubernetes cluster. So just a word of caution is that while that will give you vanilla, plain, simple Kubernetes kind of exposure, it doesn't mean that applies to a lot of the vendor setups, especially OpenShift. OpenShift, particularly, Red Hat was super concerned about security when they first launched OpenShift, I don't know, 2 or 3 years ago. But it wasn't based on Kubernetes when it first launched, FYI. It wasn't until version 3, which I believe was a 2017, 2018 launch, when they were using Kubernetes. But most of the upstream to downstream contributions for security came from Red Hat. So let's see, do GCP and other managed Kubernetes have their own global PKI? Is it per deployment CA? I don't think I know the answer to that, actually. Have their own global PKI. Oh, the managed ones. Oh, the managed ones, I don't know. I don't think it's a per deployment. Actually, that's not true, actually, because I know for a fact it's differentiated. They definitely are pulling from PKI, but I think each cluster ends up with its own set of like certificates. So I think that each deployment actually ends up with its own unique set of credentialing. They're not doing sharing.
Yeah, I realize the word deployment is a bit overused there. I meant, like per customer, right? Like I'm a customer of GCP and I want a Kubernetes. Does that Kubernetes that they manage for me have like all their Google PKI and some big secure scheme, or do they regenerate one just for me for that?
It's a sub off their big PKI infrastructure. Yeah.
Okay.
But just to say this, if you use their managed Kubernetes, you don't get to see some of that stuff. Like they don't peel back the covers on some of that, right? If you roll your own, you can, right? But for example, you don't really get access to the masters when you do when you use like EKS or ECS, right? The Elastic Container Service, the Elastic Kubernetes Service, you don't get access to all aspects of the masters. So the answer is that I don't know, because I don't think you get to see it, actually.
I see. Thanks.
Yeah. And because when you spin up the nodes, those nodes are also automatically assigned and added to the cluster. I don't think you get to see it on any aspect of the equation. But the answer is, I don't know. That's what the real answer is. But I think I've looked and I don't think you can actually even see that information. Yeah. OpenShift, by the way, you can, because OpenShift is installed. But if you're running on their dedicated platform or Rancher's dedicated platform or any of those dedicated platforms, for the most part, they prevent you from seeing most of that information. But then, of course, validation and auditing requires you to partner with them in order to ensure that happens. All right. Other things to think about. In that example I gave, where those guys scaled up to 600 virtual machines, by the way, they didn't have the proper like quota limits on there. You can actually set not only on a like per pod basis, you can say, I only want this guy to use 2 gigs of RAM, and I want it to only use like 2 CPU cores, like at most. But you can also specify restrictions on the max number of replicas if you need to, right? And so look, from a horizontal pod autoscaler, you can actually only scale up to this size. You can set min and max. So, and then of course, limits for which users and accounts run applications. I mean, that's kind of a no-brainer, actually. What namespace is it in? What user has access to what? I said there were 2 things hard in Kubernetes: networking and security, right? And that's because there is no default or de facto format or way to attend to all of this within Kubernetes. It's still very much a little Wild West. We've learned some things over the last couple of years, but there's no like rubber stamp way. There's some things we know. There's a bunch of things that we don't know. Does that make it risky to run Kubernetes? Makes it risky from 2 perspectives, right? One, the application code that's in there and the services that you expose. That's exactly how it makes it risky. You can control other aspects. You can firewall and lock off the master and node relationship. If you externalize etcd, you can control the network configuration communication there. But where it gets tricky is when you're an admin and you control all the infrastructure for a cluster, and you're like, how, but you need to let users in there to like put their applications in. How do you control making sure the users don't escape from the little jail box, right? And then when you expose ports for them, how do you, that's really the main concern, is like, how do we make sure those services stay up, and how do we make sure they stay in their little sandbox that we've created? Those are the really the mitigations to think about. And of course, when it comes to cloud and all the rest of that, like your like other infrastructure components, that's a little bit outside Kubernetes. I mean, you need to think about it. Obviously, it needs to be part of your overarching strategy. But that's the other thing that's hard inside of cloud, for example. You may have heard me joke. I said the first thing is that the things that are hard in cloud is billing and security, right? That's because you can't, this is a different way of running infrastructure than we've seen before. So particularly if you're using a managed service, you're not responsible for security of the cloud. You're responsible for the security of the stuff you stick in the cloud. So doing things like, encrypting data, using customer manager keys, client-side keys to manage your data, making sure that you're encrypting disks, right? When you like on your Kubernetes nodes, like encrypting the local disks, right? That encrypts them, by the way, against Amazon, right? Now, of course, if they can get to memory, potentially they could actually rip the keys out and do whatever they needed to do, but not the way they're doing separations of duties and concern. It's going to be hard for a single or even a team of Amazon employees to get in there and rip your key out of memory and do something with it, right? So in general, obviously, but you still want to follow your best practices. Least privilege when it comes to users on all levels, right? That includes the container, the cluster, and your infrastructure. Obviously, making sure that from a network perspective, you're isolating and creating very tight and lean tunnels with firewalls and encryption, both in the tunnel and at data for any data at rest. That's important, right? Making sure that you're getting clean segmentation there. Obviously doing everything you can to encrypt any data that sticks in SCD. Most of it, by the way, it does end up being base64 encoded. Obviously, if you dump it out, it's proto-buffed. That's just serialization. Base64 can be broken, snapped open easily, right? But I think the most important piece is just making sure that there's encryption on all layers and making sure that you're really tightly controlling the firewall channels inside the interrelationship between your cluster and also how you expose services. And I cannot emphasize this enough. Using WAFs, using like web application firewalls, particularly because that service entry is not going to be a choke point for distributed denial of service attacks. It's also for DDoS. It's also going to be an issue for any layer 7 attacks and any like attempt even to escape into a shell inside that container. So putting web application firewalls in front of your load balancers that are exposing your services, and then even having a DDoS mitigators, which by the way, AWS has, Azure has, Google has. By the way, that could even be using a content delivery network, not just a specific mitigator to basically block malicious traffic, but putting everything on a content delivery network also can help prevent overwhelm, right? You can like force caching to prevent overwhelm against your service. So there's so many considerations there. Now, I think it was last night, which seems like a while ago, I gave you a list of awesome security, Kubernetes security resources that is curated pretty regularly. Some of that, by the way, is in Brazilian. So if you see BR, como se chama, right? It's in Brazilian. So if you speak that or want to watch it, good luck. But there's a bunch of stuff in there. Like you probably saw Kubernetes the hard way and other pieces because the topic is just so massive. So while we're only kind of skimming it here, just know that you're, we'll get to best practices at the end, but you're going to need to be able to craft a lift for what's present today. Like even in that conversation that Tom and I were having, where he was like, look, they ran an attack against the masters where they were able to schedule pods on the masters, but for some reason that doesn't work anymore. Why? Well, we were speculating that probably now the master nodes have been tainted. When did that start? I can't even find that in the release notes, by the way, for Kubernetes. When did that happen, right? But that's a good practice. Even if it wasn't happening in the release of Kubernetes, checking to make sure that the nodes will not be able to actually schedule any user-based pods. That probably goes on the list of actions that you probably want to make sure are blocked and mitigated. So it really does require your own evaluation. There are multiple checklists out there for Kubernetes, but I haven't seen a complete one where I haven't basically had to reinvent or start my own. Plus, it also depends on the organization's policies. Okay. So main takeaway, make sure all your data is encrypted, both across the network and at rest. Yeah, I'm going to post some checklists, definitely, Greg. I'm not going to leave you stranded. Obviously, the curated list that I gave you is probably a good starting point. There's a wealth of information on there. I know it's overwhelming, but there's a lot there if you're looking for a particular vector of attack, or if you're looking to understand some aspect of Kubernetes. The main thing to remember is that you want to encrypt everything in flight and at rest, and you want firewalls in between all of the components that are very tightly slotted to only allow access between those components. And then for any exposed service for Kubernetes in particular, you need to consider at the very least a WAF and possibly some kind of DDoS mitigation, either through some kind of tooling if it's offered by a provider, or even going for a CDN. That's just cluster considerations. For your containers, your key takeaway is scan upon build, right? Know your sources, scan upon build from trusted sources, and then make sure you're scanning the running containers to make sure there's no deviations. They're supposed to be immutable. They're not supposed to change. The only data that's supposed to be written and that's supposed to be persistent is what's in the data store. The rest of it's all temporary garbage that should be able to kill and stop. I will tell you, one of the greatest things that has saved me time and time again from people being able to get into containers is me bouncing containers. I actually had a situation one time where someone put a Rancher cluster out on the network and it was in production. And I was explicit. I was like, please don't put this out on the internet. And they did. And someone came in, got it, and spun up a bunch of bit miners, right? And I couldn't figure out how he's getting in, but I realized he was killing production traffic. And so I just started bouncing all the containers. Why? Because I can, right? So I started bouncing the containers behind all the services while someone else was troubleshooting the access problem. And guess what? Whatever he was executing, I guess it took a second to run and it prevented him from basically getting into the system. So one thing to note is that cloud recommends this for different reasons, but like your ability to kill and restart containers, particularly for non-persistent data, is a great inhibitor because when you kill and reload that container, it comes off the base image, right? You're back to golden from your perspective. So even if you don't have a running container runtime, you can basically restore and mitigate just by like often doing that and restoring everything back to a known good state, right? So don't be afraid to not only do that with your container setup, but don't be afraid to do that with your masters and with your nodes in particular, right? the ability to basically scale down and scale up and be able to re-provision and repurpose these systems, even with something like an etcd database, is a huge help. But in order to do that, you have to be really good at automated provisioning. And so something to think about is that, this whole DevSecOps movement that you see, DevSec ML ops, right? Because now we're throwing machine learning in there, that's being thrown around. I, for one, welcome it, because I think security should not be an afterthought. And I'm not just saying that because of the audience. I've always believed that, right? And so, but automated provisioning is the best way to get there, because then that way you can also enforce security standards, make sure all your data is encrypted, make sure everything is TLS'd, and then all you need to do from that point is just verify and make sure there's been no drift from your initial provisioning. How's the best way to test drift? Kill your resources and restart them. Kill your resources and restart them. Kill your resources and restart them. Guess what? They're not drifting if they're getting killed every couple hours, right? All right. Last thing probably to mention is that in terms of access management, is that since everything pretty much is an API and an object inside of Kubernetes, we're mainly talking about, when we talk about access, we're talking about API management. So whether it's the dashboard or kubectl, or even just frank raw curl, right, that we were talking about earlier with or without proxy, just make sure that you're using TLS across the entire set. Mutual TLS is the default. If you do Kubernetes the hard way, you'll see that. Every user needs to be authenticated. Make sure things like system unauthenticated, like none of those unauthenticated users even have a chance to even do anything. By default, I think it was as late as like 1.6 of Kubernetes, both the group and the user for unauthenticated, I think they had to have explicit authorization in the context of RBAC and ABAC to even function. But again, verify those kind of things. You can roll in at mission controllers. I think I also mentioned this about OPA and OPA Gatekeeper, which are kind of the new way. Yeah, hold on, let me paste this in. This has been around actually since 2019, but this is kind of like the new way. It's been around since 2019, but as of 1.17, like these are new ways in which we are kind of like getting around at mission controllers, or evolving a mission controller is probably a better way to say it, and basically creating policy and governance for Kubernetes. The Open Policy Agent has always been a staple ever since it was released. I think since 2018, maybe it was 2019. But like these are standard mechanisms for basically controlling governance and policy enforcement inside of a Kubernetes cluster, but in particular also with authorization, access, etc. So this also, by the way, can check things like, do you have permissions to do what you're trying to do? Should I grant you the impersonation capability if I need you to be able to do something temporarily? Do you have the ability to do that? So in general, it's just like management of access policies is going to be a huge deal inside of Kubernetes. Oh yeah, there's a lot here for the OPA. What a complicated topic too. Okay, so we talked about this before when I talked about networking and firewalling and making sure, right, that everything's encrypted. I would, by the way, disable. So there's two ports that are available on the API server, right? You can go localhost 8080, right, by default, and you can go secure port 6443. Obviously, you want to disable 8080. Bypassing all authentication. You must have host access. No, I just disable that, or at least put a firewall it out, block it, do whatever you need to. But that localhost 8080 can be problematic, especially if someone can get access to the host that is running the actual API server. That's problematic, right? So all these requests, as it stated, bypass authorization and authentication. Obviously, the secure port, the one that's externally available, 6443. So, by the way, you'll sometimes see that switch to like 8443, but 6443 is the default. That has to go through all of the emissions controllers, or sorry, the authorization controllers for Kubernetes. So, but it's really that internal loopback 8080 on the actual agent where the API server is running. That can be disabled. If for some reason you have some kind of special requirement for that, then, you know, put something in front of it. Like, I don't care if you put IP tables or something so it can't even like run, but you've got to be able to control that access, because it's a little bit like having super user access against the API. It's horrific. Let's see. Obviously, Kubernetes is accessed through a variety of different tools. TLS we talked about. Client certificates, security tokens, JSON web tokens. Oh, requests obviously that fail authentication are returned with 401. So, so once authenticated, you must have like authorization is checked to make sure that if you have the privileges necessary to do the things that you've asked to do, right? So it does actually look up the security policy information, right, for the user presented the request and see if it's allowed to, like, it's matched. Like, do you have permission to execute the API that you've asked for? Do you have actually that like action, that call? So as we saw earlier when we're doing curl, you see that you have to submit a token. That token is tied to an identity, right? And that's what will allow you, a context, if you will, that will allow you to do the thing you're looking to do. So this is an attribute-based access control policy. Basically says, this is linked to a user group's privileges, right? So it's got user Scott, who is in the namespace this, and basically it has read-only access to a particular resource. Yeah. So any create or update requests by Scott are not covered by the policy and will not be allowed. Requests by Scott that match the policy are allowed to be processed. So basically allows Scott read access to pods in that particular namespace. This is a start on good scoping, but do we need him to have access to everything in pods? Or do we need to do like pod spec, for example, volumes, or pod spec, whatever the metadata is, right? What's the resource that Scott really needs access to? Again, this could be a good starting place from a generic standpoint, and then you could start with further refinement. Let me reiterate this, something that I said from the beginning. Most shops are not going to give users even indirect user access to the Kubernetes cluster. That is not common practice. Common practice is that you get access to a platform that delivers into a Kubernetes cluster, but you're not going to give your enterprise users access to your cluster. It's just not going to happen. Why? Because of the separation of concerns and other kind of like attack vectors that they don't want to have to deal with. Besides, most developers don't want access to a Kubernetes cluster. What they want is they want to deploy applications. Now, you might be different, and I know there are exceptions to the rule. And I've stood in front of many developer groups and had them be like, no, we have access to our Kubernetes cluster. We don't want to lose access to that. We want to be able to at least look at what's going on in production, which is totally fine. But once you give them a frictionless way to deploy their code, a lot of these concerns were about like, how do we scope users properly? They go away because you're not going to give them direct access to a Kubernetes cluster. That is the most common method that I've seen across dozens of enterprises to grant Kubernetes access. Role-based access control, which is contrasted with this attribute-based set, right? Allows access to resources based on a user's role in an organization. So you basically set through the role and cluster role binding, cluster role bindings, right? Resources, right? A role resource does define permissions within a specific namespace. So that way you do a namespace, they've got a role in that namespace, right? The cluster role can define permissions within a given namespace, but the cluster role itself transcends namespaces, right? It itself does not exist within any namespace, and usually it has access to things beyond. So use a role when you want someone to do something in a specific namespace. Use a cluster role, obviously, when you want something to go cluster wide, right? Greg, because they'll have no idea what they're doing. Yes, that's true. Yeah. I mean, if they want to play around, they can do kind or a Minikube or anything that they want. And again, I'm not knocking. I think it's great when people know the platform they're delivering to, even if they don't have access to it. But again, I mean, most of us are information overloaded. So when I go up to the developers, I say, look, you're not, I'm going to give you a really great platform for delivering your code, but you're not going to have to manage the Kubernetes cluster anymore. They're like, that sounds great. I've got other things to worry about other than managing like the Kubernetes cluster. Great, take that off my plate. They love that. Here's a role example, by the way, for RBAC. So notice the API version is shifted away from ABAC to RBAC. So here we're setting a role, which is going to be namespace specific, right? Not that cluster roles can't, but they run across, right? This is the default namespace. The name is pod reader, right? And here's some rules, right? So this basically, someone's assigned this role has read access to pods in the default namespace. So the resource is pods. They can get, they can watch, they can list pods. Well, it looks like they're just a reader. They can't actually create anything or delete anything, right? Or really manage anything. So here's a cluster role example from an RBAC perspective. Again, notice we're still looking at the same API version. It kind of shifted to cluster role. The name of this is just called a secret reader. And again, we basically have someone who can basically get, watch, and list and read all the secrets inside of an environment. Ooh, Tom, what are the pros and cons of doing attribute based versus RBAC? I don't know that I could rattle those off the top of my head, quite frankly, for the pros and cons. I think just because we tend to be more user centric, I think we tend to think of role based access control as being easier for us to think about and manage. Because one is where you get attributes based on the particular resource, and the other one's where you're like you get assigned a role basically in order to execute. Role based is by far more popular, like way more popular than attribute based. But so I definitely see RBAC as being one more commonly used in the community by a fair margin. I don't have a good like pros and cons list to think of just like how basically how we think, where one is tied to the attribute and one is actually tied to the role. We tend to think in roles, like we think about people doing things. We think about we even think about applications as people, right? This Python app that I had was doing this, this, and this. So we're going to assign a role to it. And we think of it that way. Like it's a, it's a thing we have a relationship with. We don't tend to think of like, well, pods, I should allow John to do, like, we don't think of it that way. We tend to think of it in reverse. It's funny that you mentioned that because some of the cloud providers had that as well. They had two ways of doing things. You could create like a user group and a role and assign permissions to access certain things inside the ecosystem. And then they had it where you could assign basically attributes to objects and grant them permissions. And it was like so confusing. This is back in like 2006, 7, 8, 9, right? Where it's like, which authorization method do we use? Well, what did everybody default to? The old one is dead. And now everybody just uses user groups and roles because that's how we think about it. I'll get you a better list. I'll get you a better answer, but I don't have one just rattle off the top of my head. Because it is a fair question. And I think it doesn't come up a whole lot anymore because everyone just uses role. All right. Now, obviously, if you created a role, which has a set of permissions associated with it, you have to associate the role with a particular user. Right? So in this particular case, you have to do something called either a role binding or a cluster role binding, which is where you bind the role to the entity in question, in this case, the user, right? So the name for this is read pods, which we had already defined in another space. This is the default namespace, right? Or role-based access control. And here are the particular subjects. So the kind is a user, the name is Susan. Here's the general API group and just refers to RBAC in this particular case. So by binding this, right? Again, this is a role reference, role name pod reader, right? This is all referring to the like subjects. So this is the role reference for that user. So this role binding basically allows Susan here to have access to this particular role, pod reader, which we defined up here. This was pod reader. And in pod reader, they can basically get, watch, and list pods. Note that it says the pod reader role must have already been created for this binding to be successful because it's referring to an existing object, right? By the way, just so you know, Susan has to exist as well, right? For that to function. Although I've seen some weird behavior from that. By the way, if this was a cluster role binding, same thing. Just change the kind to cluster role binding, bind it to the user. Right? The only distinction is that you might not necessarily, you could limit it to a namespace. You could like put no namespace there. You don't need that. Like for if we were going to go back and say, hey, I want to actually attach secret reader, same thing. Just remove the namespace definition here. Change it to cluster role binding. So you may know that you can impersonate people inside of Kubernetes. I don't necessarily see people using it a lot, but people do use it, right? So you can specify security context settings to control how things, like what things can be done, and by setting a security context field in their YAML specifications. So you can actually set security context within a particular pod or container. The run as user, by the way, defines the user ID for the user that will run processes in the pod's containers, right? By the way, to make sure I was clear about what I was saying earlier, using run as to impersonate has a user, I don't see that using very often. This I actually see used quite a bit, right? Where basically we're saying, look, we're not going to run as root, right? We're going to run as a particular user ID on the system, right? Same for group ID, right? You can also specify a different group ID to manage storage volumes, right? And this is part of the pod security policy specification, which is an extensive document. If we were to click on this and look at it. Oh, wow. You note fast, didn't you? This basically allows you, and notice that it says here that it's in beta. I think 1.20 has been out for a little bit now, right? So it basically you defines 3 levels of objects for how things run, right? But you basically can get really granular about the particular section, like the different actions that you can run inside of Kubernetes, right? So you can enable pod security policies, what that looks like from an RBAC perspective, define the policy in question. So a bunch of good examples here. This might be a good example to run through if you're looking for a deeper dive, because I think someone specifically asked me about pod security policies. There's a question here. Do the K8s management capabilities like OpenShift and EKS make the authentication configurations more streamlined than these manual methods? OpenShift definitely does. OpenShift does a lot of things to lock everything down the way that it's kind of best practice in the industry. EKS might do that, but you don't really know because you can't really manipulate the masters in some of the key aspects. This is a managed Kubernetes service. So there's some limitation of like what you can see and what you can do against those clusters. OpenShift is an installable product that actually you can install on your machine if you had 32 gigs of RAM and an extra like 6 cores laying around. And with OpenShift 4, they really kind of made that thing a little bit of a hog. It's ridiculous. Regardless, OpenShift does actually simplify the authentication configuration and enforces out of the box a much better pod security policy than like just standard Kubernetes. EKS, AKS, and GKE, they abstract away a lot of that. Now, their restrictions are mainly focused on preventing you from getting around and messing with their infrastructure, which of course also prevents attackers from getting in and messing with their infrastructure. Because people have gone out there and started out containers and tried to escape into AWS's infrastructure. Wouldn't that not be a treasure trove of information if you could get all of Netflix's like user profile information? I think that would be like spectacular gold. Now I would never do that, but regardless, that would be awesome. So AWS is getting tested all the time. So their authentication configuration, when it relates to getting into their system and getting out of the sandbox, is much stronger. As far as like how you set up policies for your particular app in relation to what you're looking for, that's a little bit more informal and isn't really streamlined inside of EKS. So OpenShift, yes. EKS and AKS, not so much for you. So a lot for the providers. Okay. So that answers the question though, by the way, right? Obviously, we want these things to not run as root or any other privileged user. We want them to run as isolated as possible. Now, last piece of this is the namespace declaration, right? So within a pod, you can just declare a namespace, right? Or specifying the namespace when you invoke, like when you call the YAML file or do a creation manually, right? So if you don't basically specify a namespace, it's going to use whatever your current context is. It's usually default, but you can switch the context on your kubectl to have the default namespace be something else, right? So if you don't specify, it's going to go back to your default. That's usually default for most people. So because you saw now how roles basically allow you to assign permissions to a namespace, you can see that actually namespace, like sometimes, by the way, they call it as namespace as a service. Let's take a huge cluster and give every like project or product its own namespace, right? And then let's create roles and users that are associated with those namespaces. And by the way, if there's multiple projects that a single user has within an organization, you just associate the role from those projects to the user, and they can then access those namespaces inside the cluster. I will tell you, again, that OpenShift probably does this spectacularly well. Rancher and the others less so. Certainly the cloud providers don't really change anything there. But there are several advantages about slicing the cluster along those partitions and forcing them to stay into that, into those partition sets. And it does, it does enable, by the way, users to basically in teams to act like they're like, hey, this is our tiny little cluster. This is our cluster, right? And the only way that they can interfere with other systems is if you don't put any resource quotas by default around their resources. So you're just allowing them to basically kill the entire system by making pods go rampant. Obviously, if they escape through some kind of 0-day vulnerability or other CVE, they can potentially get access to other parts of the system. But that's really the only official way, like if all the roles and the namespaces are set up correctly, that they could like cause issues with the system is if you don't put resource groups on their stuff. So you want to put resource quotas on. By default, by the way, you can force a Kubernetes pod to have a default resource quota for anything that started. Right? I would highly recommend that be a de facto practice. It could be 1 core and half a gig of RAM. I don't care. But like if you do a CI/CD system to deliver into Kubernetes, make it so that it applies a default resource quota to anything that's put in there if one is not specified. That's the other way in which you can really kill yourself, is giving someone unfettered, unrestricted resource access to your cluster. Because then someone could run an 8-core 32 gig system or 128 gig system. Next thing you know, it's eating all the memory on the system. And now you've been DDoS just because you forgot to constrain the user, right? Oh yeah. Initial namespaces, right? You've seen all these already, right? As far as kube system and kube public, and there was one for dashboard and stuff like that. But like by default, the default namespace is what you're supposed to use if you're messing around for default applications. Those namespaces, especially kube system is one that you definitely don't want anybody getting into if they can help it. It's not the last step of defense, but if they get into that namespace and they have permissions to do what they need to do there, that's where a lot of really sensitive items are running, right? And so you want to be proactive about making sure they can't get into that. Let's see. You've seen me create namespaces before. That's not a big deal. You've seen me delete namespaces. That's nothing new there. That's probably worth mentioning. I love that. It's the last little line just sitting at the top of the page. If you delete a namespace, it does actually delete all the resources in the namespace as well. I don't know that I've actually done that before. I know I was complaining earlier about namespaces being such a challenge, but I don't know that I've actually deleted a namespace that contains something I thought was really important. Not yet, anyway. By the way, let's see. Remember when we were running the command earlier we were running the command kubectl API resources. And there was like a list of like, hey, can this be namespaced or not? Right? This is a little namespace, this third tag here. So there's a list of things that can and can, I mean, like, to be frank, most things can be. But there's a couple things that can't, like, service reviews and certificate signing requests and ingresses and priority levels and stuff like that. So you can look at that full list if you want it. Most of them are namespaceable if they're objects that are related to deployment. If they're objects related to the cluster, like certificate signing requests, that's not going to be namespaced because that's a cluster wide thing, right? Most of those are fairly intuitive, right? But like pods can be namespaced, whatnot. Sorry, let me close that. Hold on one second. I got a phone ringing in there. I apologize. But anything related to deployment for the most part can be namespaced. Oh, there's the command that we were talking about, API resources. Didn't even see that at the bottom of the page. Oh, I think I showed this already. But if I run a kubectl get pods, right, it's only going to show what's in the default, right? If I run a -a, I think I showed this already. It's going to show everything in the system. We think we've seen this already, right? Note, by the way, I just want to point this out. What's in kube system, right? Everything is in kube system. So. Oh, yeah, yeah, that's probably, I'll save that for another time. We already talked about the amazing things that namespaces could do for you if you use them. You can offer namespace as a service in your cluster. So organization, isolation, security, partitioning, resource control, etc. Yeah, okay. While we were not rushing through that, it did seem to go pretty fast. So we skimmed the surface about roles, role bindings, cluster, I'm sorry. Yeah. Cluster roles, cluster role bindings, right? We skimmed the surface on that. We talked a little bit about like basically how you can do attribute versus role-based access control, right? Skimmed through a few pieces around that, talked about namespaces in particular. And we kind of like skimmed a little bit on like the different aspects around access management. Most places that I work with, by the way, federate, they do a webhook into their Kubernetes cluster into another system, and they create roles for the users in question. So the user database is now hooked in, it hooks in, provides a token, and then that's assigned, that user ID from that external system is assigned a role, right? Ahead of time. That's how most people like federate their Kubernetes clusters. They're not using Kubernetes for its amazing user management system. They're using an already existing user management system with some scoping, right, on what the users can do. And then we talked about namespaces and just how you can virtually slice and partition your cluster. Okay. We do have a lab. We do have a lab called Planning and Designing a Kubernetes Cluster. We're going to use Kind again, right? Those of you who have missed Kind already, we're going to use it again, right? By the way, this might be a good opportunity to take a 7-minute break because we only got like 30 minutes left, right? By the way, I will not be offended. Some people are like, you know what, my brain is toast, and so we're done for the day. So I need it to check out. I would recommend that you do actually do this as like if you can right now, while you're still actually in fresh context, right? But if you're completely burned, right, you can always do it in the morning if you need to. But you're going to get your clusters. Make sure you like look at the current context, right? Get nodes for your Kind cluster, and then basically just look at the particular namespaces that were created here. You're going to create a team 1 namespace, right? And then you're going to get your context for kind RBAC. Oh, and you're going to generate a key file for a particular user, right? Because certificates is basically how users are managed inside Kubernetes, right? Not really necessarily an object, which is an interesting statement. And then let's see, going to associate that with a certificate authority. And then we're going to be looking for the files we're looking for can be listed in this command for when you're actually looking for the CA files in question. Going to copy the CA files, right? List all the CA files there. basically create an X500 certificate file for the user, right? And then create the user's context for the user A Jackson, right? Using RBAC, in particular namespace team-1. And then you're going to do some work as a restricted user to get a feel for what you can and cannot see now as that user. So it gives you a feel for what a user would look like in your particular cluster. Then we're going to create a role and a role binding, right? Using some files which are going to be listed here to create the role and the role binding in question for the user in question. And then you're going to basically run as that user in a deployment role. So you can see what's like if you granted permissions to a user, being very specific, what would like granting permissions as a deployment manager, for example, what would that look like? That's it. That's the lab. Okay. This lab actually does take about 30 minutes, of which about 5 minutes is starting the cluster. 3 to 7 minutes is about starting the cluster. So go forth and get into lab 7. And we'll go from there. Let's see, they still need to map users to Kate's privileges though, right? That has to be done in Kate's. Yes. Yes, you'll see, Greg, when you go through it. Yeah, basically, that's exactly right. Get to the point where you start kind and then maybe go take a 5-minute break and then come back. Yeah, if you haven't already like inferred that. Awesome. Matter of fact, I'll be back in just 5 minutes and grab a quick glass of water.